Actually, they don't want to start this. Say whether you get more bases to work. Good and bad. The good thing is the budget. The bad thing is
okay. Good morning, all. My name is Yang, and I'm a data scientist with MOHT. Very warm welcome to the digital phenotyping workshop today. The thematic lead of this workshop is Professor Robert Morris. For those who do not know Robert, Robert is the Chief Technology Strategist at MOHT, and at the same time, Robert is also a faculty professor at YLL School of Medicine. On behalf of Robert, we would like to thank all of you to be here in such short notice. And we would also like to take this opportunity to thank the AI for Science team, Professor Kedar, Professor Subodh, and Professor Yang Zhang, and also the Academic Research Division, Hans Lim and Fadila, for making this workshop possible. So thank you all for coming. To kickstart the workshop, I'll ask Kedar to give a few opening remarks.
Thank you, Yang, and thank you very much. But we really appreciate you all here. I won't take much of your time. I hope this is a nice space that it's going to get cooler as the day goes on, because they turn on the air conditioning around 8 o'clock. But a colleague of mine said it's cozy, so hopefully you enjoy the interactions. Again, thank you so much for Yang and Robert for doing this. Really appreciate the ecosystem coming together at very, very short notice. But it's a bit of an aggressive timeline, as you'll see and you've heard. So essentially what we're working towards is defining what AI for Science in Singapore would mean, right? And the idea came like about 6 months ago. We wrote a scoping report, and this should not be domain specific. So we're looking at a national program for AI for Science. And we've now opened up a website, so aiforscience.sg. Please access it. It's being updated. The workshop itself will also be updated on there. So, please take a look at, you'll have photos from today and the interactions, the notes will be captured today as well. And hopefully we'll have the recording available on there too. Let's see there. What's the slide of that? There's which computer? I can do it from there. I'm pretty loud, so I don't need a mic. Okay. Yeah, so we started off, actually, this is in February this year. So I went to Japan, and Professor Hiroaki Kitano, some of you might know him, he's the founder of the RoboCup, right? So the idea here was that, can we actually, come up with a scientific discovery that's actually done through AI, right? And he called it the Nobel Turing Challenge, because the Turing Challenge is the level of a Nobel Prize. That's sort of his vision, and we kind of thought that's a good way to synchronize with him and discuss this. And maybe some of you know this, but I checked, Robert, your profile, and you were involved in IBM Watson, which is one of the earlier sort of developments in the space, beating Grandmaster Kasparov at chess, for instance. So we've come a long way. So thank you. Hopefully this feels like a little bit of a closed circle here. That's kind of nice. And what we have defined AI for Science, and we spent some time thinking about this, is that we want to have AI to solve scientific problems towards scientific discovery, right? And we wanted to differentiate this initiative from what we call foundational AI developments. So developments in architectures of AI for this, which is also interesting by itself, but it's under the realm of AI, for example. There's a few chairs up here. So move back. And of course, differentiate that also from AI for X. AI for X, we think of that as applied AI. So, what you typically see in various different domains is that you can take existing tools, make a package, or apply it for advancements in a particular field. Those are great as well, but we do not want to cover those in this initiative. And that's why we're bringing leaders such as yourself to come here and think about this in more detail. Next slide, please. And so the way this is being scoped is both top-down and bottom-up at the national level. So there are obviously some areas of interest. So health is one of them. Climate could be another one, where the government is really keen to explore what does AI for Science mean in that space. But there's also been a lot of ground-up sort of domains that come up. So physics, complexity science is one. Phenotyping was another one. So in those cases, what happens is that you're looking at different domains and thinking about what AI for science means in your particular domain. Right? And it's really a combination of all of that. And these workshops are meant to facilitate this sort of discussion. Next slide. So what we're working towards is actually this AI for Science Nobel Turing Challenge conference that's going to happen on the 23rd and 24th of July this year. So please mark your dates. We'd love for you to be there and join us. The date is already fixed. We are collecting speakers globally. So we have confirmations from Microsoft Research, NVIDIA, some of the leading people from Caltech, etc. have agreed to actually speak as well. And so we are drafting a nice set of people who are going to come and speak at the workshop. But what we're really hoping to do is to draft a foundational research capability report. So this is a national report. It's facing everybody. It's public facing. So it'll be sent to all the government agencies. It'll be sent to all academics and internationally as well. So myself and Professor Zhang Yang are responsible for writing this up. So we'll really look for feedback from today's workshop. And Robert, who's a thematic lead here with Yang's help, we can actually put it together and we'll have a white paper that comes out of the discussions today. And that white paper will be integrated into the full foundation research capability report. So it's really an open mind brainstorming session today to think about what AI for science means. Next slide, please. So you can see the website again, aiforscience.sg. We've had about 15 or 16 domains at this point. So, I've done this about 10 times already. Next slide. The upcoming workshops, this is not updated because the date's not updated, but you can see them all on the website again. So the key thing here is that we're looking for a vision statement. So define a problem statement, okay, that actually is solved only through AI, right? And what facilitates that is, of course, data and HPC. That's what you see at the bottom, right? So what data sets are available? And in health, actually, I'm envious. I'm a material scientist, and you actually have some very good data sets available, which you could use then for material scientific discovery, right? So, and HPC resources. So please be as quantitative as possible because this actually will be put in the report. For instance, to say that this kind of hardware, this kind of new architecture is needed for you to solve these grand challenges. Right? So the idea really has to be transformative. What we're really hoping to do is to seek ideas that are transformative, 10x improvement in something or an advancement that is not possible before. So please keep this in mind. And when you have a discussion, and I think I mentioned this to Young before, I think he's actually going to facilitate this, but essentially keep this in mind when you have your discussion sessions later on. That's basically. That's my last slide, if I'm not mistaken. Yep. With that, if there's any questions, if not, I'll hand it over back to you. Thank you very much for your time.
Sorry, Michael, you have.
Sorry, I'm going to question you.
No, of course. Please go ahead.
I kind of get when you say data sets available or to be curated in your journals. I don't think you should.
Okay.
I think health data sets are really weak, extraordinary. And I think the real problem with all the issues we're facing, we're talking about menopause, etc., are looking at transitional states, whereas health data is all end state. So my suggestion would be is what biostatisticians used to get really annoyed about was that people would design studies without consulting them, then hand them the data and say, please analyze. I would suggest that in these dialogues, you get people who are involved in both computing and in generating data sets. Because the problem is the funding agencies look and say, what can you do with existing data sets? What they don't do is say, what type of data sets do you need to maximize AI's do?
So that's very good feedback. So I think I should probably mention is we do want to do this by design. So the last workshop, which has been pushed because of so much interest from the ground, is an AI methods for science workshop, where we're getting all the AI practitioners from Singapore to come in. And the feedback from today will be fed back to them to get their buy-in as to how existing methods or new methods can be developed. There is no restriction here that you cannot say that data sets are not good. You can please do say that and say that there needs to be an effort to generate that data. That's a completely plausible thing to say as a part of your.
Well, I think you need to design data set and data collection to map on to the needs of AI.
Right, absolutely. I completely agree with this. So one form of this is multimodal data, and that doesn't exist. So a lot of communities are doing this. So I think that's, you please put that in the discussion. Yeah.
I just wanted to add because we were talking earlier about so the data we have there, so I have to read so obviously while we need the AI experts,
we can give the ideas, the suggestions, because
A, we know data is not clean. B, it may be permutation of data, right? So we're talking about chronic diseases. So you have diabetes, for example. Yes, you have a cognition data, even you can get that from EPIC. And then you have a nutrition data, right? And we also know that certain data may be specific to certain age group, because we do find that, say, above 75-year-old, chronic disease is no longer relevant as the function that's relevant, right? So I think it's good to have workshops with a hybrid of, and we kind of co-create together. Just feedback.
No, that's a great idea. I'm not sure if there's any AI. I don't want to put anybody on the spot, but hopefully there are some AI experts in the room here. I know Rick is one there, so please talk to Rick. And there's a few others, hopefully, but please do give this feedback. What I really hope is this is the beginning of the discussions, right? So this is the start where we get the domain experts in to talk about the problems. Please state those problems. We will bring that to the team, and we could have further workshops as a part of this where we can actually engage with them further. So this is just the beginning of the discussion.
Thank you, Kedar. So now, without much further ado, I will invite the thematic workshop leader, Professor Morris, to speak on the motivation and drivers of this workshop.
Can you hear me? It's not working. Oh, how about that? So I'll start off. Actually, we have a tremendous diversity of people. I was looking at the enrollee spreadsheet. So we do have a lot of AI experts here. We have all manner of healthcare experts, data science experts, statistics experts, etc. So we're very well equipped, I think, today. And I just thank you for squeezing into this tiny space. You can see how oversubscribed this whole program of AI for science has been. And that's why we are like finding ourselves constrained in a small space. So with my co-author, Jimmy Lee from IMH, I'm going to take you through a journey. And it's to get basically all of us on the same page. Some of you will know this code, what I'm going to talk about. Others of you, it'll be more educational for. Right? We're actually going to go through this journey. Look, we have the tech. We have some data is very good and some data is sorely lacking. And you'll see why the data that we really need is, are the mics working yet? Not working. Okay. Can you hear me in the back row? Okay. All right. So some of the data we really need is what's the most lacking. Okay. And we're going to work through and actually show you why that is specifically for healthcare. We're going to go back and look at the bigger picture, which is what really matters in healthcare. And that'll direct us to see what we're not getting. And then I'm going to start with the healthcare we receive, which is only determines about 10% of our health outcomes. Some people say 20%. And then I'll switch out to what about the rest of our lives? From now on, what does it take in terms of data for us to understand? There are very young people here. There are people who are on in years like me. For us to progress through those remaining years in our life and how to optimize that. Put it all together, look at what's happening from the patient's perspective, and then look at bringing all the data together through this concept of foundation models, which have been very revolutionary. The idea that if you can gather enough data of all different types, you can start to get some profound insights, actually actionable insights out of that data. I'll show you a reference models for AI-based digital phenotyping. By digital phenotyping, we just basically mean measure everything, right? Everything about the phenotype. Gen AI is starting to work quite well. It's very controversial and it's saying some stupid things, but it's also saying some very smart things that we haven't figured out. Humanistic bots are just emerged in the last couple of months, and they're very exciting. If you've heard Kevin Roos's podcast on Kevin's Friends, it's quite remarkable on Hard Talk. I'd recommend that to everyone. And then talk about how foundation models are the goal, but we're not going to have access to all the data in the foundation models. This is a problem. We won't have access to the data without breaking the law, like some of the biggest tech companies are stealing the data today. Well, not to name any. So we probably will not do that in Singapore. And of course, some of the data is rightly proprietary, belonging either to the publishers of the 35 million healthcare papers, or the EPIC Systems is here. They hold a lot of data on behalf of many different fine organizations around the world. and end up with a grand challenge. So let's start from the beginning. So we have the tech, okay? I have a lot of amazing tech, ranging from data analytics, machine learning, good old-fashioned AI, which is still very important for what we do, rule-based systems, very basic AI methods in learning. But Gen AI has taken the world by storm. And in fact, foundation models are the goal for a lot of specialized topics. Did we get sound back? We're working on it. Okay, that's fine. The tech's not quite here. I shouldn't say that, right? Of course, that can be used for all these areas. Can you see in the back? They have some screen. It's okay. Cloud has made things incredibly easier for us all to get access, and not just to the normal stuff in cloud, but also deep learning, for example. Sometimes we need massive amounts of accelerators, and we can't afford them. The rumor is it's costing $1 billion to mine for OpenAI's ChatGPT-4. The next $1 billion for the next 1.5. That's the rumor. We're not going to be able to get the data that we're looking for, so we're going to have to get bursts on cloud. 5G is fantastic. I no longer pay attention to my data consumption. And it's not just because I've got 5G, right? I've got all the data I need. Didn't used to be the case even a few months ago. But also 5G is offering all kinds of other things. We can now do sensing because the power is much lower, the battery life is much lower. We can do all kinds of sensing things that we couldn't do before. Some of the best risk devices are still very power constrained, and technology is going to march on. And these are a few of the sensors. We're going to refer to some of these sensors. So a lot of this kind of AI in science, a lot of it got started with grandiose claims about drug discovery and what is happening, how in the drug discovery process, we can actually improve the biomolecular target search before we even get to the in vitro testing, the microarrays, etc. And we can filter, we can find new molecules, we can filter out things that are unlikely to bind at the binding domain, etc. And we can do some rather remarkable things by not just by doing ab initio calculations, but also by doing pattern matching of what happens in folding, what happens in binding, etc. And in fact, it's controversial. Some people are saying it's work. Some people are saying the hits are really no good to me and I can't use them. But a few new molecules have been discovered. But still the rest of the process, animal models, clinical trials, etc., AI is not helping that much, maybe helping a little bit. As we look at health and as we look at the process of sensing and intervening, and by the way, this is a research talk and a research enterprise to try to do what we're doing in this AI for science, but it's actually all about what it's really doing. And the reason, the difference between lifespan and we're destined to live long and live good. Can AI help with that? So we're going to talk about a model for automatic discovery of biomarkers, basically what should be measured, how we can do feature selection, inference for conditions, say relapses, interventions. The whole thing is, yes, it's all very good to find laws, publish nice papers, get promoted in academia. We want to change outcomes at a lower cost. Change outcomes because we're all going to suffer through this period, and we're all suffering unnecessarily. A lot is not solved in healthcare. We don't know much cost. Healthcare is going to bankrupt every country in the world if we let it go on at the rate it's going. And it will raise the GSP, the point in Singapore with the World Program. Very unhappy. So we're going to claim that actually most of these steps that we need to do to transform healthcare are going to be highly AI is highly important to address those problems. So that's what you're going to see. Still no sound and it's not. Yeah. Sorry. It's going to advance my slide.
I don't know. He went to get something. Yeah.
Okay. So this is something which has been discovered by many authors, not a new result. And it comes in many different ways, but it's something along the lines of the following. If you haven't heard it, you remember it after this modified model, the board most popularized by Stroger, and it's all Guinness original 15 years earlier. And it's all very, very general principles, some would say it's kind of obvious, but it's based on analysis of huge amounts of data, including event analysis on that data. It just basically says the following. If you look at the contribution to premature death in years life loss, about 40% of that, some people say 50%, but a huge amount is due to activity. So that's 40%. The next biggest part is genetic predisposition. How we show that. So what we're born with, and it's not that we can't change it, and it's not that we can't see a genetic breakdown, but very important. 20% social circumstances and environmental exposure. Social circumstances. You know, it's true in Singapore, it's true in the UK, it's true in the US. People with low socioeconomic status have a lifespan that's perhaps 20 years less than people with average life circumstances. It's a tragic thing. It's not well understood, but it's a fact of life. People, poor people who don't have who are younger, worse. And then finally, environmental, which is like the air that we breathe, which is not often the cold. But more importantly, the heat is coming, and we're starting to understand.
Hello, sorry about this. We cannot hear on Zoom.
Environmental, and then finally, 10% the healthcare we receive. And why is that? It's because often it's too late. And it's a very important thing. This is not the important. Once you get sick, it's the most important thing you can do. It's a very important thing. And it's one that we find. But remember, a lot of the course is already set by the time we have that very important with the doctor that changes that. So what can we do about it? Sorry, we're not advanced. There we go. Okay. So there's a set of terms about how we measure each of these things. One is called deep phenotype, which is the healthcare we receive. It's basically all measured in the electronic health records and some other records as well, but largely the electronic health records, of which we thank our EPIC colleagues who are here today for doing such a fantastic job around the world, and many other companies and many other systems that keep track of those records. So you can do deep phenotyping, you can do predictive knowledge. Genotype, yes, was defined in 1909. Okay? Very important comments. And one we're going to talk quite a bit about today, visual phenotype, moment by moment quantification of the individual level phenotype in situ as you go around the life. Like all what the old research maybe something is Fitbit or Jacqueline's smartwatch, which is very Apple Watch. And other personal visual devices, of which, by the way, the phone is this thing knows more about your behaviors. It's a good step to this device. And it knows a lot about its ability. So go forward. Next slide, please. Okay, so let's start with the smallest pizza slice, the healthcare that we see. Next slide, please. Okay, so this is an example of a predictive model done by someone in the audience, probably Deorani, which says that if you are diagnosed on day 0 with diabetes, what's your chance in the next 10, 20, 30, 40 months of getting either cerebrovascular disease, ischemic heart disease, kidney disease, or just. And it's comes up quite fast. This is based on 3%. Kind of get from a subset of Singapore's 3 million longitudinal of 12 to 18. This is just a small set. It won't change with most of the data. So it doesn't tell you when you're going to get that uncapped, but it tells you the probabilities each year. And the AUCs of these numbers actually quite good. 0.75, 0.85. Next slide, please. Okay, so with all of this, with machine learning, if you then take into account the kind of vector in the EHR of the patient, namely things like age, gender, ethnicity, it does matter. Okay, your HbA1c, your LDL, your creatinine, etc., and your diagnosis history, and you can throw in other things like your labs. Okay, the labs that you see further with even more information. You can throw in the drugs that you want, etc., and you can do even more accurate. Okay, what you can do is you can start to build tools like this. I'm going to show you one very quick tool that financially reduces point of care. It does the following. A lady, Mrs. Pan, aged 54, has come in. And Mrs. Pan has actually quite high LDL cholesterol, and she has high blood sugar. Okay? And actually, she doesn't take her cholesterol medication. Like about 50% or fewer in Singapore take their cholesterol medication the way that we do. Okay, so what's happening with her? These are her risks. She's at a very high risk of getting ischemic heart disease, probably have a heart attack. Okay, and she's also at moderate risk of getting chronic kidney disease. Okay, so what can we do? Well, we can talk about please stop having your tablets, or please review your prescription, or please take your cholesterol medication. And next slide, please. Okay, she comes back 3 months later, and the LDL is down. She's actually got the message about the cholesterol level, but LDL is down, and she's now borderline risk between orange and red for ischemic heart disease, right? Chronic kidney disease is still about the same. So the next goal for her, according to the model, the best thing to do next is try to reduce the blood sugar, get her HbA1c down from 7.0. So through a discussion on that, or perhaps a prescription of a medication, or maybe something, we managed to get in the next visit. Next slide, please. We managed to get the HbA1c down to 6.5. Doesn't sound much less than 6.5. Actually, predictably, it makes a huge difference in terms of both kidney and heart. Right. So this improved lifestyle, if we can get this across, these are actually risk factors, or probably have huge potential. Next slide, please. But actually, we've tested this, we've tried this, used in some cardiology centers in Singapore. It's actually hard to get to work. And the reason it's hard to get to work, many of you read Daniel, and he shows in there through examples, which I think we all know, that humans are very, very poor at reasoning, understanding probability, reasoning probability. The classic examples are like the non-use of basal, the classic problems area. About 80% of doctors overestimate the chance of failing on first by 1,000% based on the data and sensitivity. And we all do it. And by the way, PhDs in statistics also have to get it right. It's a question which should use data. A multiple problem, many problems, very basic problems. We get wrong. Whether and how you describe it. If we say 20% chance of for a certain cancer treatment, you have 20% chance of one or 80% chance of survival. You get very, very good. So how do we get that across? Daniel Kahneman says no one ever made a decision because of a number. They need a story. And in fact, in the clinic, it's even worse. For someone who only has 8 minutes, often our appointments in the clinics are 8 minutes long. You actually don't just need a story. You don't have time for a story. You need an action. And the next best action. Okay? So we talk about some of that today. Now let's talk about bigger slice of pizza. The rest of it, I'll add 40, 20, 15, but 60%, right? Visual, and this is all going to be measured with digital phenotype. Let's see what it's doing. Well, now it's working. Okay, so here's an example. This is a project, IMH is the first one today. This is going to be IMH, and MOHT. We have been, actually, this is where AI is needed to speed up science. For 4 years, 5 years, we've been working on this, and we've done over 3-year clinical trial. We collect the data. It's very new topic. Digital phenotyping as a subject is really only about 5 years in terms of practice. And so we've been collecting digital phenotyping data on psychosis, which psychosis is things like schizophrenia, serious mental. And what we've been doing is we've been collecting it through wearables and smartphones. And we have actually modeled whether or not we have the ability to predict relapse. Why do we want to predict relapse? Because we can intervene. What would cause a relapse? The person has stopped taking their medication, maybe they ran out, or they decided to take it anymore. Or there could be some other thing. There could be some trigger, or there could be something unknown in the life. We can see the relapse that we have shown on the data that comes up there. When we see it, what do? We can do a couple of things. We can intervene at the end, something. We can also, sorry, as well as that digital phenotype, we can also ask them how they do. That's also about case of EMA, assessment. And if we have the data, we can intervene it. For example, if they're not sleeping, we can get them asleep. We have 45 sleep to make it deliver on the phone. If they're feeling agitated, you can send them a phone. But some things can be done at the edge. Not everything can be done at the edge. And if we get the machine learning right, we can actually have a dashboard. We can have colleagues who are called connected care monitors, the psychologists, senior psychologists, they can see a dashboard every day. They can see how people are doing. What the machine learning does is characterizes them as red, yellow, or green. It says why. So we use machine learning for that. And that enables an overload, make more careful with it, which I think is in a patient. There's a lot of other things you do with the patient as well, helping them do this. They can call them and say, what's going on? Or whatever. So how does that work? And then does that work? Next slide. So this is a set of data which should convince you that it works. Basically shows, in terms of detecting a relapse, we can detect it with the best techniques with about 90% sensitivity and roughly 90% specificity. When we get 90% of these relapses, maybe we can prevent and the relatively small number of false alarms, the false alarms are not that bad. So this works. And you might just be interested in what do we actually measure? What are the main variables? It's not a surprise. Happiness. So psychosis and it's three problems. Negative symptoms. Not too bad. So cognitively, you tapping your phones. Well known. Schizophrenia, the way we got many drugs as well. Tapping your phones. So we can measure that. Home time. People with serious mental illness don't go out. They don't communicate with text messages. They don't sleep well. Okay? They don't always exhibit all of them, but they exhibit one or two of them. If you put it together, you get very unsensitive. You're going to see more of this. Next slide, please. Okay, one more thing, safety, regulation, etc. This is an interesting case of how you have to work away from and skirt around this swamp of regulation and safety. Because what if that black box, big machine learning algorithm, by the way, works on 250 million events? What if it goes astray or has a bug or so it's interesting. What we do, we use hand-coded rules for doing regular things, which are coded up by clinicians. And they work, but they don't have very good. And then we only use the machine learning to test it. Okay, so the machine learning only pushes you up from green to yellow or red to red. See the safety in that? The machine learning genetically gets them. So as long as you don't have to do false alarms, you can get the sensitivity of the machine learning. That's the kind of thing you can program. Or you can take the posture to the head of the whole eye and make it easier. They need to see this before they'll let this. Okay. Putting it all together. So patient journey. Is this the next slide? Okay. How do we put it all together? So I don't know. This work was something Schroeder about what the numbers are. Some of you know what some of you want, but there's something else. Some of you will know. There was a landmark study by the Rand Corporation in the US led by Dr. Creighton, which showed that actually, even though we tremendous amount of work to create guidelines, what should we do with this kind of cancer? What's the best practice? Patients usually only see about 50-55% of that care. You do a very careful study, at randomized study, people are under cancer or GP clinic or wherever, cholesterol, applicability. Compliance with guidelines for different diseases, the average about 55%. And I liken this whole story of finding out what to do, cognitive overload in the doctor's office, where there's so much data, no way you can absorb it. So no way we can expect, they do a very good job actually, but no way we can expect them to do the right guideline at the right time. And the patient doesn't stop paying attention or doing anything. So you kind of get Napoleon's march. Napoleon set out from Paris, and by the time he got to Moscow, he lost 70% of his troops. And by the time through the winter, by the time he got back, he had like 3%. It's a little bit like that, maybe not quite so bad in healthcare. We've got all this data, it's massive overload. We don't know how to interpret it. The guidelines for hypertension are nobody can follow them. No, they can't follow them. Put all that together, plus the 35 million patients. Recent results. This is no longer recommended. There's definitely no way you can get other than the incomplete best care guidelines compliance. And then the patient adherence is low, and then the outcomes. So what can we do? Well, many of you, particularly those in AI, heard about foundation model. In fact, an LLM, all the LLM I can promise is actually from large language models, which is kind of foundation. Foundation model says if you can get enough data, huge amount of data that really conveys a huge amount of experience that you can capture, you can put it together fairly simple, like auto-addressable predictive model in AI. And you can actually start to do some very interesting things. Some people even call them emergent things, right? So what does that mean? This is from the Stanford project on foundation model, which articulates a very high level. And it says, for the example in healthcare, all these source care providers, farmers, payers, wearable sensors, all the wearable sensors that we were just talking about, images, ultrasounds, genomic sequences, ECGs, everything, put all that together into a foundation model and try to come up with something better. And for us, what does foundation model mean? Of course, it means all the longitudinal health record system. But it also means all the medical literature, 35 million papers. People are half of which are wrong. In other words, they've been overcome, or they're not maybe reproducible, or they're out of date. So the question is, it's all very well to have that 35 million. You don't want to just turn it all over. And the people who are best practicing that have also been paid. They're very carefully looking for papers that are attractive. They're looking for papers that haven't been confirmed. They're looking for drugs that are phase 2 of the Prenatal that haven't passed phase 3. And you probably all know about the stories with diabetes and what's the most metformin and diabetes, which was still cancer for 17 years, to all those real-world evidence drugs. So a lot of the data, there were hundreds of a lot of the data has been over alternative ones as well. That means that the applicability and so we need to do that in a very sensible way. We want the omics data, we want all the behavioral data to cover the 60% that we just spoke about. We actually want the world's data. We want all the data on the world, so we can treat English or some other language as well. So we now bring you to a reference model for how all of that works. The reference model, it's actually being practiced across the report. It works as follows. It works through the life course. We're going to start with -0.75 of Michael Meaney books. Gestation of the health of the mother and the baby. And it goes through to Prof Robert 100 and beyond. So we're going to talk about the whole part. There are all these diseases, which some crop up for the lifetime, some for the later stages of life. But we have one general method, which says we measure either actively or passively with a ring, a wrist, blood pressure machine, etc. We measure in situ, so we get real valuable data. And maybe some of it's just question and answers, so it could be something active. But everyone has it. And there's a lot that you can do locally on the software in a very private way to provide immediate feedback, so-called MPH. But sometimes you want to bring it up into the cloud and deliver the latest therapeutic, okay, or the latest advice or the latest suggestions, whatever. And sometimes you even want to bring it to the hotline. So we're doing this for hypertension, diabetes in Singapore, every public day. We give people a blood pressure machine, we give them a blood sugar machine. Thank you. We give them a blood pressure machine, blood sugar machine, etc. They take it home, the data goes into their smartphone, they get some rule-based advice locally, and then it may go up into the cloud and they get more advanced advice. And it also goes onto a panel for a nurse who can pull them in early. And by the way, it's working pretty well. It actually decreases the visits with better outcomes. So you come in less often, you get better outcomes if you're willing to keep this little proof. So we're practicing that in primary care, where we've launched the digital phenotyping you just saw since last July in the Institute of Mental Health. And we want to use this kind of technology for every disease we can get our hands on. And so while we're at it, we'll get these improved outcomes and lower costs, like I just described to you. We'll also build a foundation. Okay, we'll all contribute to the foundation model. So that's the basic principle and the basic idea of what we're trying to accomplish. Okay, and there's a few things going on at the same time that are going to be very useful. So Gen AI, just in the last couple of years, has actually the average, this is on the Medline Stanford test. It's a test of about 200 golden questions, which have been very carefully vetted, that physicians should be able to answer. And by the way, they do very well. They get 78% of them right. But the LLMs are starting to get better and better. So these are the closed ones. Med2 is now called MedGemini. They keep renaming it. And these are open source ones. So even the open source ones are doing very well, which we can get and run those ourselves. So quite interesting, quite promising. Of course, it doesn't replace the doctor because you still need to convince Mrs. Peng. You need to understand her personal circumstances and convince her, take everything else into account that the LLM isn't taken into account. And do it all in some automated way, but including the clinical picture. And one last thing, actually, in preparation for this workshop, we were challenged by actually Dr. Creighton Heaukulani, who's my co-author here. He said, you know, we may never be able to get all that data that we need to really fulfill this. It's going quite well, actually, in some of the advisory, but for less common diseases and particularly for behavioral health. So what's the difference between behavioral health and like drug discovery? In drug discovery, we actually have ab initio model. We have a physics model for how a drug agent, a molecule, would dock with a receptor binding domain. And we can reason with that. In chess, in Go, we can actually have a very basic model of what's a correct move, what's not a correct move, and what is a game position, and how to evaluate it. So we have all of that, right? We have a little bit of that in healthcare in human physiology. We know a few paths, we know some paths in cancer, some pathways which are very important. We know a few endocrinological paths. We're still very, very far ahead of the model. Then we go to behavioral science. And by the way, later, Daniel Fung, the head of Institute for Mental Health, will show you that actually mental health is the highest burden of disease of any disease in some. If you add it up, it's the highest. It's higher than chronic diseases, cancer, in terms of use of disability. So it's disabling our lives, and it's the contributor to that lifespan minus health span. So if you then take something like behavioral health, and it's a wide range. Some people have a diagnosable illness, anxiety, depression, etc. Some people just like every one of us have setbacks. We have some depression, we're under stress, we're not at our optimum performance because of stress. Our kids have exam stress. Our suicide rate is sadly very, very high amongst young people and old people as well. So much we can do, but we do not have a model. We don't even have a model for the synaptic cleft and how the different neurotransmitters work. It's almost a mystery. And then on top of that, you have to build all the learning behaviors, and then you have to take into account all these, social stressors and exam stress and job stress. That boss, who's driving me nuts, etc. So all of that, put it all together. We don't have a model. So what can we do? So we were challenged to. Can we go back to that second last slide, please? What can we do? So we go back to Go. Go was very interesting. It was different from chess. Can you go to the second last slide, please? Go was very different. In chess, you go as deep as you can when you use an evaluation function, find the best way to pick the world. In Go, the branching factor is so high, you just can't do it. So what you have to do is you have to build a strategy, and then you have to refine the strategy of this kind of move, this kind of move, this position, etc. And what they did in AlphaGo is they played one strategy against another, and they used reinforcement learning to build the strategies. No, not that chart. Previous chart, please. Okay. Now, do we have a model of human? Actually, we have a model of human. If you listen, I referred before Kevin Rose's friends. We actually have very conversant friends now that are constructed, and they can actually tell you a lot about human behavior, how humans feel, ranging from friendship. You can get a coaching friend to coach you in your career. You can get an erotic friend. You can get all kinds of friends. You put them together and they work with each other, and they have quite human behaviors, and quite strange in some ways, but also somewhat human behavior. So what if could you go back to this? Yeah, this one. So what if we reason between those, either as a training process with a therapist, because there are therapeutic methods for which there's scientific evidence that they work. Cognitive behavioral therapy, ACT, DBT, schema therapy. These things actually do work, not perfectly, but they help. Not everyone will help much. So what if we had people train from these tools? Early students were trained from them. What if we had advanced therapists, successful therapists, train these agents? And then what if we had the agents work together to create new strategies? Would that work? That's a way of perhaps challenging this problem, because actually training on almost all of the web, and they are training on almost all of the web, even behind the paywalls, not entirely. We're building a huge repository of human knowledge. So next slide, please. So how does this work? As a screen, this is a very dense chart. So once you build this, you get these conceptualizers, very big foundation model. What do you do? The first thing is you can't get all the data. Ethic can't release all this data to us. Some people are stealing the medical journals, including those behind. But we're not going to do that. But we can get some. Composed or curated version of that from reputable publishers who license that to us. So we can reason we can't work with a pure LLM style, pure foundation model. You could put it all in purest approach, you put it all into a neural network with an attention model, images, everything to see what comes out, right? And you train with outcomes that are reported 3 or 4 years later. Mrs. Tank did end up having that. You train with that. And you also train with human experts, not the way it's been reinforcement learning with human data. not with the ones where it's being done today, but with experts. Okay, and you build this fantastic model. Yeah, not doable at the moment, but we can do half of it. We can do part of it, and the way we can do it, go back to these fantastic time series models that are available. For example, Cosmos, 246 million patients. Tune and derive true risk models based on that, and find out for Mrs. Peng, a female, 54 years old, she's got this current data. What is her risk? Okay, and then put that into the. We know to focus on AHD, right? Then what should we do about AHD? So we can work with large language models, clinical key, case notes, etc. Mine all of that. Maybe even use some bots, which are about the fact that she doesn't like taking medicine, human behavior, and how we might have to coach her. We see this later, this kind of coaching. And then give that as care considerations to the doctor and make the recommendation. So we'll wrap up last chapters. So this is the grand challenge. How can we improve healthcare outcomes and costs by improving productivity of research, all the discovery of the models, the treatment models, the deep understanding of disease and human failings, towards foundation models? Maybe it'll take many years to get to foundation models. Using sensing, because if you don't have the data and you don't know what people are doing during the 60%, you can't do it. And then deliver not just research papers, AI-based interventions in situ. You get, and you'll see that later on today. All orchestrated with AI. That's the range for us today. Thanks.
Thank you, Professor Robert Morris. Apologies for the technical issues earlier. So moving on, we would like to invite Dr. Alfred and Professor Lian to tell us more about Empower, nudging for chronic diseases. And as a side note, we got to know that Dr. Alfred and Professor Low was the winner of the AI Grand Challenge stage 2A about 5 years ago. So we have a lot to learn from them. So let's welcome them.
Yeah, thanks very much, Yang, for the very kind introduction. Hi, everyone. Sorry I couldn't be present with all of you at the workshop because of what. But Alfred is right now, and I will pass the time to the president.
Okay, this will do for now. Okay, so the Jarvis project is actually the initiative that we made for Empower. What we did is that we actually developed this technology-based intervention system. So what happens here is that we actually look at a series of initiatives to create a sustainable and cost-effective strategy for behavior intervention. So what happens here is, what we do here is actually quite similar to what Professor Robert Morris had last mentioned about developing this system for technology. So we have this series of data sources that we collect from the ground. So this includes like focus group discussions. Oh. Okay. So what we do on the ground is that we collected data from the ground. So this includes focus group discussions, as well as using a mobile app technology that collects various kinds of data. So this includes physical activity data, blood glucose, blood pressure, and various kinds of behavior patterns that the user collects on a regular basis. Now, using all this technology, we then actually developed this tool that incorporates a series of technologies to create this follow-up intervention. So with this in mind, right, we actually developed this Empower platform. Okay, it should be advancing now. So what we do with Empower Plus is that we actually create an AI engine within the platform to actually deliver a series of personalized nudges, smart food prediction, and contextualized health advices. So we actually use AI to develop a series of features that actually takes all of this data from the ground and then actually outputs them as some form of health advices for the target users. So later we will illustrate in the demo some of the 3 key features that we actually use to actually employ the AI as a form of the intervention. Now, we also actually do some validation tests with the Jarvis, with the Empower Plus prototype. So we actually do this with a resource-controlled trial about 1,000 patients. That was conducted about 2 to 3 years ago. Currently, we actually do follow up with a series of ongoing clinical trials. Now, we also do have some initiatives, but this is actually part of the current larger scale initiatives that we do have for the Empower project. Now, to actually, let me see if we can advance. So Empower actually comprises of a series of features, but the focus will be primarily on the food AI, the AI for chatbot, as well as the AI for nudging. So this is actually the series, the umbrella series of features that we do have for the Empower platform. So this includes your regular series of login behaviors like physical activity, blood glucose, blood pressure, etc. Now, we also have some form of features that actually follows up on the data that is collected from the ground. So this includes like a chatbot, goal setting, motivation interviewing, etc. So that's for the individual level. Now, we talk about interactions between the patient and the healthcare worker or healthcare professional. We also have a series of features to facilitate the interaction between these 2 parties. So this includes like journal. So we use a journal to actually log the behavior and compile a report that can be viewed between the patient and the healthcare worker. We also have intelligent nudges. So this is actually sent autonomously by the system, which we will show a bit later on how it works. And then we actually have a way to actually demonstrate all of this information via multiple interfaces. So one of them is a mobile app for the patients, as well as a healthcare workers portal for healthcare workers who wish to interact with the system. Let's see. Okay, sure. Now, to actually illustrate, just to give a bit more context on how AI is actually designed and implemented within Empower, I will use one of the features that we have, which is a notification-based feature. Now, in the case of notifications, what we do is that we have a baseline data model that we built from the ground. So previously, before Empower Plus, we do have a prototype app called Empower. So that was heard as part of a previous study that we did together with SingHealth to develop this machine learning model. So what happens is that we have 1,000 data, right? Now, with this 1,000 patients worth of data, we actually can construct a baseline model that we can use to train individualized behavior models for each patient. Now, with this, we can then create contextualized and individualized machine learning models for each patient based on the behavior that happens. So what happens here is that using that 1,000 patients, we first identify the significant factors from the data. So this includes things like your physical activity behavior. We look at the days of the week, whether you're active or not, and we match to the objective of our nudges. So say, for example, right, you have a notification that want to nudge you to wear your tracker or increase your physical activity stack count. This is one of your most common notifications that you receive on the platform. So with this, right, we can actually use rule-based rules to actually determine whether we should send that notification or not, so that we can just remind the user to increase their stack count. But let's say if we do this every day, then it becomes too much. It might lead to a form of nudge fatigue. So we want to address this problem by creating nudges that are more smarter, they are more contextualized, and they are more personalized. So what we do is that we first try to look at the data and identify the factors that can contribute to the behavior. So say, for example, if they exercise regularly on Mondays, Thursdays, Fridays, then these are the factors we might want to extract. Now, we also look at whether more contextual factors, like say, for example, if the behavior is happening on a public holiday. So those are the factors that we can extract from the data. So we do perform logistic regression. We also extract principal component analysis to determine the contributing factors. Well, with this in mind, we can then train this with our local ANN model. So actually, we do have an individualized ANN model constructed for every patient, right? So from the baseline model that we collect for that 1,000, we can apply all of these factors to derive individual models for each patient that can change with time. So every time when a person performs new behavior, say for example, when I wear my physical activity tracker and I walk this amount of steps, I can use this data to train a new model for each patient over time. So you can imagine with this, let's say a new trial or new group of Empower Plus users who have 100 users who use the app, right? You have those 100 users with the baseline data at the start of when you start using this data. Now, as time progresses, you get these individual behavior patterns that can be trained into each model. So what happens is that over time, this 100 users will change. So you get 100 different behavior patterns and 100 unique ANM models for each person. So this is actually how we use that machine learning to create more contextualized machine learning models. But what do we then follow up with these machine learning models? This is actually similar to what I think the beginning study shows about the follow-up. So we use this model to actually create interventions. So in this case, we create these notifications, right? And in the backend, we actually do have the rules, but that rules that are based on the ANM models to actually determine when to send the nudges. So returning to the example that I mentioned about the physical activity stack count or the reminders to wear the tracker. So now I can actually identify you are more likely to wear your tracker on Mondays and Thursdays. So I will not remind you to do it anymore, right? But if you're not going to be likely to wear your trackers on Wednesdays and Fridays, then maybe I should be more likely to remind you to nudge you to do it. So now I do not have to remind you to do it every day. Now I can just remind you to do it on Thursdays and Fridays when I found that you are less likely to do it. So everybody is going to have their own individual model to actually realize this behavior. Now, from the ground, we actually do a field study in terms of predicting the accuracies of some of these nudges. So we actually tested this on our 1,000 patients to try to establish the accuracy of the nudges. And we found that usually for these nudges, there is the prediction rate between 74 and 85%, depending on the behavior that is detected. Now, I explained the example earlier in the case of wearing your tracker. Right, but if we look at physical activity, we could be looking at an alternate pattern. Say, for example, if you're looking at a person who is more likely to not hit the stack count, we want to actually change the stack count threshold to remind them to actually hit a target, for example. So this is actually where certain behaviors like the stack count reminder or whether they actually submit activity logs comes in. So we use physical activity because this is actually where we actually are able to get the most amount of data from the activity trackers, as well as because they are actually advised to wear the trackers regularly. So with this data, we are actually able to actually establish this prediction. So it's about 74 to 85 to 89. We can then use this data to actually train individualized models for each of these patients falling forward as they use the app. Now, we also actually employed this study in a follow-up study with the 1,000 patients to actually see if their HbA1c actually correlates with the predictions of the model. So in COVID, we found that if we look at the intervention and control groups, where the intervention people are the ones who actually use the Empower app versus those who don't use the app, which is the control group. So they are usually the ones who actually use the Fitbit mobile app. Now, we do see a noticeable decrease in HbA1c over time. So this is actually more noticeable from baseline to month 3, where the HbA1c drops better for those from the control group. So we do see that the use of the Empower, especially with the use of the individualized nudging model for at least for notifications, works for those with severe diabetes in this case. Now, actually just now as I explained the application of AI within the use of notifications, which is the smart nudges. Now we do have 2 additional applications of AI within the Empower Plus platform. So let me actually now switch over to my computer over here to actually demonstrate how we actually apply AI nudging with the Empower Plus platform. Let me just see if I can get the screen. Okay, so it looks like it's working as intended. Now, unfortunately, I think I probably will need to drop my mic in a moment, but this is actually how we use the Empower Plus platform. So this is the mobile app that the patients use to actually interact with the system. So there are 2 front-facing systems, right? The first one is actually the one that is used by the patient. So this is actually the mobile. Every user who actually has installed the Empower Plus, they can actually log into their can log in with their Empower Plus account. So this is administered by us. Now, here you actually can see how we actually create the input section for our AI model. So this is actually where the user can create data inputs. So for example, right now, right, if you use a Fitbit tracker or Apple Watch, you can actually look at the stack counts, etc. that is logged inside. Alternatively, if you're looking at in terms of behavior, right, you can actually input various kinds of behavior, such as blood glucose, blood pressure, and so on. Now, let me focus on the application of AI in one of our logging activities, which is food logging. Now, commonly, you can actually do food logging in your own way, where you can actually just key in your food items and, just key in, just search your food from there. Now, we can do so with our food database, but we find that to be relatively tedious. So what we do here is that we can actually use the app to actually detect the food item that is in our picture. So this is actually where we actually use Smart Food AI. So I'm now broadcasting this live, and let me just attempt to take a photo of this carton. Now, it doesn't matter how bad the quality of the photo is, but our food AI model will attempt to actually look at the food that is captured and then try to detect the food that's inside. Now, how we do this is that we actually tie this to our food AI model that actually detects the food that actually has a compilation of various food images. So in this scenario, what we do is that we actually have a database of about 50,000 food pictures that is tied to 3,000 food items. So this really varies according to the various kinds of food pictures that are available. Sometimes we have food that has only about 20 to 50 images because the food in question may not be very popular among users. Now, if we talk about food, say, for example, like milk, right? You can look at your commercial milk cartons, etc. So those are very easy ways to actually source certain various pictures. So in this case, it is easier for us to identify the milk carton as possibly either full cream milk or low fat UHT milk. So that is actually how we can actually use our AI to actually try to detect certain kinds of food items. So that's actually how we actually can realize we use AI in one of our ads logging features. Now, thirdly, I think one of the more common technologies that we see these days is the use of GAI or generative AI. So we also do use GAI. However, we employ GAI in a little bit differently. Now, what we do with the GPT model in Empower Plus is that we actually use a localized GPT model that that uses a local corpus of about 1,300 health items and documentations that we compiled together with SingHealth. So what we do here is that we can actually ask various kinds of questions in the Empower Plus chatbot. Like, for example, I just type what is diabetes, or say, let's say if I type a question of what is high blood pressure. Now, again, the chatbot is able to actually differentiate different types of typological errors, etc., and try to determine the best matching question. So this is actually how the system will then try to respond. Now, we currently also think about trying to advance the model in our system with prompts or trying to actually, with a feedback system to rate if the response given by the bot is good enough or medically certified. Although we do take measures to ensure that the local corpus in our system is as localized and curated as possible. So that means we do not need the information from OpenAI, Google, etc. We only use the database from our own internal system to actually curate the information within the health bot. So this is actually the major applications of AI in the Empower platform. So we do have other features, but I think for the benefit of time, we'll focus on these three major applications on AI within the platform. Now, this is actually where this is actually where I will stop my presentation to talk about the Empower Plus platform. Now, I'm not sure, Dr. Low, if you have any additional words or comments to say. Okay, so if there is none, then that's all I have to share for the Empower Plus platform, and I'll pass the time back to the host.
Thank you. Thank you. So next up, I would like to invite my esteemed colleague, Dr. Praveen Deorani, to talk about AMI Hope.
Thank you. How do I control the slides?
Try this. Control.
We can control it.
You'll have to ask for that.
Okay, thank you. I'm Praveen, a data scientist at MOHT, and today I'm going to share about some of our work. Working all right?
Yeah.
Some of our work about patient coaching in our telemonitoring program, specifically for post-heart attack patients. You saw this chart before a while ago when Robert shared this. One of the things it says is that the biggest determinant of health outcomes is patients' health-related behavior. And that makes sense. All of you are familiar with that already. That makes sense because the chronic diseases stay with you even when you are at home, outside the clinic. But the big thing is, it is also, it can also be seen as one of the big leveraging points in how we change the outcomes of people, as we know. That not only it's a big determinant, but there's also a big gap in terms of what kind of interventions or what is happening, how much importance is given. Share your
It's on Zoom.
I think the Zoom program Sorry. Yeah. So I was saying it's a big leverage point because not only that's important, there's also a big gap in how this is being treated, the importance that it's given. For example, we know that something as important as medications, which has a lot of which has a big impact on health outcomes. A lot of patients don't even take their medicines regularly. The problem statement, I think, again, you're all familiar with, that Singapore is a very rapidly aging society, and with that comes a very fast increasing prevalence of chronic diseases. And this chart is a bit old, but for more latest numbers, you could say, for example, in 2009, the government healthcare expenditure in Singapore was about $2 billion, a little more than $2 billion, and in 2027, it's expected to be about $24 billion. So that's about more than 10-fold increase in just 20 years. And those are some of the numbers. We can also see, the need in Singapore, specifically when you look at some of these publications, these are published in last 5 or 6 years. The health knowledge and treatment adherence in Singapore from the patient side is not as good as some other rich countries, right? And so there's a lot of opportunity here. There is some more research which shows what are the reasons behind the lack of treatment adherence. And when you look at those reasons, most of them seems to be very easily manageable by patient coaching and by nudging and for behavior change and engagement. For example, most of the people just forget to take their medicines. They were out of their routine and so on, right? All of these reasons are mostly manageable. Yeah, are manageable by coaching. And so that's why, as I said earlier, it's a big leverage point because not only there's a large gap, but it also makes a big difference in how the health outcomes are going to be. Yeah. It starts with risk communication. Again, Robert touched upon this earlier. It's very hard to reason with probabilities, but often our risk scores, our risk profiling, they will tell you, what the risk score of a patient is. You can tell them the risk score, for a certain outcome is so many percentage, 17% risk of death versus 83% of surviving. It doesn't make much sense to the patient. Although in Singapore, we do have examples of, going beyond this. We have a heart age calculator, for example, and if you communicate to the patient in that way, telling them that your heart is like that of a 65-year-old or so on, whereas your actual physiological age is something else. That may make a little more sense to the patient, even though it may not be quantifiably as correct. Then there is also a case that most patients have multiple chronic diseases at the same time. And so they might also have multiple borderline risk factors. For example, they may have a bit high BMI, but not quite outside the threshold. They may have sorry about that. Yeah. Instead of having one very bad control factor, such as HbA1c of 9, usually they will have multiple borderline risk factors. And that's also very hard to reason with, at least for the patients to understand. And the risk factors for onset of a disease, when you look at risk scores and so on, but in terms of preventing those, preventing that disease or preventing the progression of the disease, sometimes it's a bit different. And so that also makes the communication a bit more complicated. But can be done. Risk communication is the first part, and again, Robert touched upon that. I'll show that in a bit. Most patients have multiple chronic diseases, as I said earlier. This chart shows, this is from Singapore's national public health care data. DHNL here refer to diabetes, hypertension, and high lipids. And when you look at the number of patients in each category, there's only very few patients who have only one of these diseases. Most patients have more than one. The dark color here shows, with ischemic heart disease. You can also talk about, kidney disease and stroke and so on, and the picture gets more complicated. But the idea that very few people actually have only one chronic disease, and that's why the idea of risk communication becomes a bit more complex. Risk communication as far as designing the intervention of what they should focus on first. And so, again, this you have seen before about an hour ago. We could come up with risk scores and show them to the patient during a clinic visit, and you can show them, what are the risk scores for different diseases and how you can modify them using risk factors such as weight, blood pressure, smoking, and so on. You can ask the patients to focus on one at a time, as Robert showed the example earlier. You could also augment this with, the modern AI. The next slide, please. Yeah. You could use this, along with the risk score, because the risk score alone doesn't make much sense to the patient, even to the clinicians often. And so this could be augmented with let's say, generative AI models, which can take information from clinical notes, from medical knowledge around the, from all the literature, from books, from Singapore healthcare guidelines, and it can come up with next best action for the patient, because the action is more important, not the risk score itself. Yeah. But it's not that simple. Even if you give the knowledge to the patient about their risk profiling, about their, what are the main risk factors, what is the next best action, and so on, that is still not enough, because having that knowledge is still not same as changing the behavior, because that's even harder. Changing the behavior is even harder. There are many factors that affect behavior change. Some of those are, the environment and so on, which I suppose, at least in the context of digital coaching, are kind of out of scope. But some of it can be managed. One of the big things is that instead of one clinic visit, it has to be more continuous. You have to reach out to these patients on a more regular basis. And for that, what we have in MOHT is we have some digital health, telemonitoring programs. And the schematic of some of our programs looks like this. That, in this schematic on the left side, we have clinician and an AI tool, which assists the clinician. On the right-hand side is the patient, their physiology and their physiology and their mindset, right? The data flows from the patient's physiology, which is basically the blood pressure they have measured, the digital phenotyping data, their health, their step count, and so on, their lifestyle. All of that data can flow into an AI engine, just like the Empower program that we saw just now. And then the rules engine or AI engine can detect certain events of significance. It can analyze the data and send the information back to the patient or to the clinician. And then the clinician can use this information to talk to the patient, have coaching, have teleconsultation, and so on. We have all of this running in MOHT, and these are some of the examples. We have a blood pressure monitoring program called PTEC in MOHT, running from MOHT. Across all the clusters, it has 16,000 patients now. This is for simple hypertensive patients. We also have a very similar program running for post-AMI patients now. That is not very big yet, because that started much later. It has 130 patients for now. And then, of course, we also have a program for preventing schizophrenia relapse, which is a completely different type of program. The first two are simple in terms of how we understand the physiology of the disease, the impact of blood pressure, and so on. The third one is a little more difficult in terms of digital data and its impact on the outcomes. But we have that, and Robert has shared some of it. Some of it will be shared later today. But basically, they all look similar, right? The idea that an AI engine assists the clinician to take care of these patients. The AI engine also directly can converse with the patient, just like the Empower program. And the data, of course, behind the AI engine comes from the patient's EMR, telemonitoring, and their health lifestyle, their phone, their Fitbits, and so on. Yeah. However, it could be, currently we don't have some of this running. For example, we don't have this program connected to the EMR. That gives us even more information if we do that. We are going to do that later this year for our post-AMI program. And that gives us a little more information, because now you understand the clinical risk profile of the patient, their latest lab results, and so on, which helps us in understanding their most recent profile. You also need to understand the patient's activation level, their stages of behavior change, and so on, which can be done because we have this AI engine which converses with the patient, the information that is collected via these chatbots and so on, or their usage patterns in the mobile phone. You can infer the states of a patient in terms of their behavior change, and you could use that as well. You could also engage the family members. That's not yet in our app, but we have that in plans as well. The family members are known to be, from research, a very important part of this journey in terms of behavior change. A lot of research has shown that. It has not been done digitally yet, but we plan to evaluate that as well. Okay. Specifically for post-AMI patients, I said that our biggest program is for hypertensive patients, 16,000 patients, but we are evaluating, or we are exploring this digital coaching, AI-based digital coaching specifically for AMI patients. It's a small program we have started with 130 patients so far, and we have been doing some of this so far. So our personalization of digital content currently is based on some of these factors, which is one of them is time since heart attack. For example, right after heart attack, you probably want to encourage them more, tell them that it's going to be all right, show them the stories of other patients who have been through this journey and they have turned out all right after years. Recent blood pressure measurements. Since this is the telemonitoring program, we have an idea of their blood pressure being measured twice every day actually for these patients. And what we do is we look at the last 14 days of blood pressure, the trends, we compare them with the previous 14 days, and based on that, we have a library of messages and we choose, which message to send in order and see what the impact is. Of course, based on smoking status and based on clinical profile. Currently, the clinical profile only means whether they have diabetes, hypertension, and hyperlipidemia, along with the AMI. But that can, of course, be more complex over time. Smoking status matters a lot for these patients, so we have that as well. For patients who do smoke or used to smoke, we have some of the content which is different for people who never smoked. And then, of course, the big one is patients' preferences. One of them is what is the health goal they have in mind. So our chatbot, our AI engine enables them to set a health goal. They go through this process of goal setting, which is known from literature, from behavior science literature, to be one of the most impactful interventions in terms of changing health behavior. So they set a health goal. We follow them up with with that health goal, and then how they have been progressing for the next 4 or 5 weeks. We have goals for smoking cessation, different sub goals for diet, physical activity, and so on. And so that appears on their mobile app, and they can go through that process. Once they set a health goal, of course, the content is personalized for them, based on the goal that they have set. So these are some of the personalization we do. Most of it is rule-based, not much of AI as of now. We have only 130 patients. We look at this data and tweak our rules. So it is data-driven, but not AI specifically, at least not the modern AI, it's rule-based. However, more generally, this could be, sorry, next slide, please, yeah. More generally, we plan to, previous one, please, yeah. More generally, what we are going to do is we are also going to incorporate some other things. Daily routine is the easiest one. Again, Empower team touched upon that. What is the right time to send these messages and so on. There are different types of messages we send, notifications, etc. Daily routine matters a lot. Some types of messages directly appear on the mobile app, in which case it doesn't matter what the time is. Whenever they interact with the app, they can interact with the material. It's a good, it matters because for our AMI patients, they are most of these patients, more than 70% of the patients do submit a blood pressure reading every day for the first 3 months. And so they are interacting with the app, we know that. And since they are interacting with the app, we could just put in some material there and expect them to interact with it. We have to infer over time, once we have more data, we have to infer over time from the data. In this app, we collect data such as where they clicked, how much time they spent on each of these articles, YouTube videos, and of course, we have information of what is the time, how many blood pressure values they submit, and so on, at what time of the day, what is the frequency. We can infer the states of patients, such as learning preferences, what kind of material they engage with most. With EMR data, we can also know the risk of different outcomes, and then based on that, we can engage them further by informing them what is the next best action, as we discussed a while ago, and then the stages of behavior change. I mentioned goal setting earlier, which is known to work for people who are already in the contemplative stage, but most patients, you will find some are in the pre-contemplative and some are in the much later stages, and so you have to have different interventions for them as well. Those can be inferred as well. If you have a chatbot, unfortunately, some of these questionnaires tend to run very long. And so we have to find other ways to infer these states. Once we can infer these states, there's a whole list of interventions from literature that we know of, for different people, what kind of interventions seem to work best. And we can do that. How do we achieve this? is the next slide, is what we are going to do is, for 1, 2, 3, I have mentioned clinical risk profile, stages of behavior change, and learning preferences. But of course, there are others which we showed in the last slide. All of this information about the patients, sometimes inferred, sometimes directly asked, goes into the patient profile engine. And the patient profile engine now knows, what the patient is like, what is the diagnosis, what is the clinical history, and so on. Socioeconomic status, education level, all that matters. And then what we can do is we start with some common assumptions in the beginning, right? We start with some assumptions that this is for example, this type of intervention or this type of encouragement matters more. We have to start there somewhere. It's called a cold start in machine learning. But over time, we can learn that based on what is the probability of action, in the sense that whether they even clicked on our material or not. Did they even read our material or not? Or based on that, did they change their behavior? What was the success of that event, right? If we send them something, what is the probability of success? So we have to take that into account as well. And the value here in that equation means it could be, for example, what is that disease adjusted life years you will gain? That is known from literature, most of it. If you change blood pressure by so much, if you change LDL by so much, how much dollars you gain. That value could be in terms of money or something. But once you have the probability of action, probability of success, and the value of that, that what is the expected return, what should you do? And then at any moment, you have a segment of one. At any moment, you will determine for this particular patient, this is the thing that I should send right now. Now, it's not as simple as that equation, because sometimes that equation may tell you the same thing again and again. You can't keep sending the exactly same encouragement, same words again and again. So there has to be one more layer outside that, but that's the general framework that we are working with, and that's how it will work. We are in early stages still, and we have seen some early results. How if we try to optimize our content for better interaction, we do see better interactions. Increase from about 20-25% to more than 50% engagement from the patient, depending on how you define the engagement. In terms of actual outcomes, we do not have the results yet. By outcomes, I mean the improvement in blood pressure and so on. Very few of our patients have actually finished more than 6 months for now. So that's where we are going. And then coming back to the slide, when you look at the slide again, when you empower the patients, you not only, 40% is not only a problem, but that's also an opportunity for us, and patients are actually a resource, not a burden, if they start participating in their health. Yeah, that's all. Thank you.
Thank you, Praveen. So up next, we have, I'd like to invite Professor Andy Ho from NTU to give his insights into behavior, wellness, and cohorts.
Well, good morning, everyone, and thank you for giving me the chance to share with you some of the work that we've been doing here at NTU. Unlike previous presentation, which is very comprehensive in terms of how AI can be put into practice and the type of data we're collecting, I do want to share with you one specific project that we have completed recently in developing an application that supports patients who are dealing with diabetic foot ulcers. And this project is called, if this turned, it's called WellFeet. You probably have read about this in the news perhaps a couple of weeks ago, and it's now hopefully being rolled out slowly across major hospitals in Singapore. So a little bit of context: 1 in 10 adults have diabetes, and about 19 to 34% of them will develop diabetic foot ulcers. Now, this may seem to be nothing of a big burden to people, but it is actually a big issue, because we have a number of record high amputation because diabetic foot ulcers in Singapore. There are 4 amputations every single day in public hospitals in Singapore for DFU. And so this not only affects quality of life and also mobility, but if you're not taking care of this, it can lead to premature death. It can also cause a lot of financial burden to people because of the lack of ability for them to go back to work. They can be mobile and so on. And there's a high rate of recurrence. About 40% of people recurrence with diabetic foot ulcers within the same year. So research have consistently found that patients are not well informed and they don't have a high level of health literacy. And by providing them with competent, effective education, it can really lead to improvement of health outcomes. But obviously, we know that we cannot get patients to read a 20-page article. Like nobody wants to read that except for us in this room, even though at times we don't want to read it either. We have no choice. And so what can we do to streamline the process of education? How can we develop content and deliver in a way that people want to learn about this? And so what we believe to be true is that digital approaches to psychoeducation can be something that's highly scalable and cost effective. So what we have now in the marketplace is that there are apps that looks in diabetic foot ulcers, but they're used to take pictures, look at risk stratification, and measuring ulcer progression. But there's not a lot of apps that actually include comprehensive education or patient support. And so when we looked into root cause analysis and look at observation in the clinics, we also discovered from many of our clinicians that there's no time and place whereby education can be passed on to the patient. There's nowhere for them to learn about these things, how to look after the feet, how to moisturize the feet, how to wear the best footwear. So that is definitely missing and in need for support. Our team received a sizable NIMRC grant a few years ago. And this is for us to look at the situation from a more comprehensive lens. We have 3 work packages. The first one was to look at the current practices of preventive care, as well as care management for diabetic foot ulcers, doing a series of focus with clinicians on the ground. We also conducted a large-scale population survey to look into how patient and caregiver are managing their foot ulcers. What do they do? What are their concerns, and so on. And from these 2 work packages, the information that was gleaned from it helped us to then design and develop a platform to deliver a DFU-specific training program for patients and caregiver so that they can improve health literacy. It can help them to engage behavioral change that aims at prevention as well as care management, self-management. So this brings us to WellFeed. WellFeed is an application, but it's also a computer content management system that provides 3 interfaces. The first one is for patient and caregiver, which is the app that people often see. The other one would be for the administrator as well as data and analysts to look at the type of data and information that user engagement data and what are the user using on the app itself, what word are they clicking, how long do they spend on each educational module, do they have, if they take a quiz, are they competent, do they obtain the information and knowledge, and this allows the admin to send nudges and personalized intervention. And it also have a platform to engage the physician, because this needs to be integrated into regular clinical practice in order for it to be actually effective. So how can we also provide a platform to the doctor to use this app and engage the patient based on the activity that they have on the application itself? So I'm going to focus on first the patient and care domain of the app. And so what we really aspire to do with this app with WellFeed is really to promote health literacy. We want to be able to provide access to a wealth of engaging and easy to understand information, as well as diabetic foot ulcer care useful information. And so what this means is we're not just simply extracting or looking at a literature search and see what article is available out there, what can we provide, what type of videos can we choose that's existing there, but we're actually looking through a systematic synthesis of all the available literature and international guideline that is available, deduce all of this information and put it into 1-minute educational video, right? Because that's the amount of attention span that we have now. If we ask patients to read a 20-page article, they're not even going to start. Even if we ask them to watch a 5-minute video, it's too long because they'll be off to do something else. So 1 minute is what we're aiming to. And within that 1 minute, they can get one piece of information that can help them to take care of their foot better. In the app itself, we also develop technology that help us to monitor their behavior, help to understand their sleep and their steps. And we want to make sure that the interface itself is user-friendly and simple and is not too complex. And it can also provide a content management system for care providers, as well as data analysts, as well as the healthcare team to engage the patient more effectively. So what about the education? Well, it's content rich. We looked into, really look into systematic reviews, systematic synthesis, and then we come up with 4 themes of 21 topics that looks in diabetic foot ulcers with progressive level of proficiency. So you start from something that's very simple. As you progress, things get more complex and you learn more. The content is multimedia rich. There's 54 bite-sized, visually appealing, and fully voiceover animation of AI avatar host. This is important because we want to be able to, for these videos to be engaging. And for there is an AI avatar, then the person feel like this is someone that looks, like a real human that's talking to me. And so these 1-minute video can be very informative. Not only are they developed by our in-house team, but it's actually verified by more than 20 clinicians in the field. So there are multiple rounds of reviewing of the synthesis of data, the script that's being written, and the video that's being produced. The way that the script is written is also needing to ensure that it's easy to understand, is in layman language and empathetic language, in a way that people feel heard. People feel like, oh, this is me, and I can identify myself within the information that's being provided. We also focus on personalized learning. So it's not just everybody go through the same pathway, but based on their onboarding risk stratification, also user engagement data, including click level data, competency data, behavioral data. I can then understand where this patient is in terms of the knowledge, competency, and behavior, and then nudge them a different piece of educational content that fits where they are now in the current status. And because of the AI that we're using, and the avatar host, we can actually deliver this content in 4 languages: English, Chinese, Malay, and Tamil. And the last one is often the population that missed out on a lot of these services because no one speaks that language. But now we can use AI to deliver it. Apart from the educational content delivery, we also created chatbots that are rule-based and evidence-based. Within those chatbots, we built in motivational interviewing techniques to encourage patient self-autonomy, motivation for behavioral change, as well as empathetic self-care. Because to look after themselves and feel they're responsible for their health is actually quite crucial. As we heard all morning, 40% of the health is based on behavior. And behavior is coming from a place of motivation. How can we motivate people to look after their health, to believe that this is my responsibility and I want to do something about it, and I can see the positive impact that comes out of it. And there's also create dialogues that are eliciting self-reflection as well as more motivation for health literacy and daily care behaviors. We have other tools, so we gamify daily tasks. For example, if the patient take pictures of the foot and document it, that's a score. And at the end of the day, they can fulfill the ring as we have in our Apple Watches. We also develop medication reminders to help patient to take the medication and also document the medication that they're taking. Feet journal, which is really to an instructional way to help patient take different angles of the feet of the foot ulcer, so they can share this information with the physician to see the progression. We also have meal diary as well. Other new tools that we're currently working on developing include medical appointment reminders, step trackers, and goal tracker. This seems simple enough, but it's actually very difficult in a way that when we're developing the app and automatically collecting it, the way that we're doing it is not directly connecting to Fitbit, if you have a Fitbit, but we're using Apple Health and Google Health, because the Fitbit automatically connects to Apple and Google Health. And using these two platforms, I can extract data from it. And that requires a bit of work with Google and Apple for the story. So that's the patient and carers platform. In terms of the main platform, what we do is we have a number of features as well. So this platform allows content management. You can upload information, new content, new information, so that it's up to date with current practices and research. So it's evidence-based and it's recent. It can also send out automatic and personalized nudges and notification to patient cohort or specific patient based on the information that's here. And we can also create a journey, a patient journey in terms of the onboarding process, learning pathway. If they're inactive, we can send them notification, and also ensure that the privacy setting is there for engaging process. So that's the main part. And in terms of the physician, what do we do? What can we offer them? So for the physician, we can really use this app as part of standardized personalized care. We can help patients set goals according to their needs. We can also use the app to track the daily health-related activities as well as foot care updates. They take pictures of their feet, have they moisturize their feet, and so on. And then the doctors can also look at this simple generated output to then provide notification and encourage their own patient to complete self-care tasks. And if we are to integrate Wellfeed into the clinical pathway, well, it can be introduced in a doctor's appointment. Doctors can introduce this app and ask them to download it and start using it. And as patients use the app, they can engage in effective learning in a self-paced manner. They can also record daily activity, food care achievement. They can monitor their food and their feed as well as the food that they eat through photo monitoring, as well as behavior reminders. And the next time they go back to a doctor's appointment, they can share all this information with the physician, and the physician can then engage in more precise medicine as well as intervention and providing more accurate advice based on the behavior the patient has done. And so we developed the platform, and we have time and funding to do a feasibility study, not an RCT, but a feasibility study. We did a single arm study that looks at how patients are using the app, the impact that it has on the behavior as well as health literacy. We also conducted a focus group discussion to understand what the patient think about the app is, how can we improve the app, and what type of technology can be enhanced. So we recruited 40 participants from Untitled Hospital, and 40 participants, including 23 patients and 17 caregivers. And so these are the demographics. And what we discovered is that after 1 month, so we gave them a 1 month period to use the app. It's all automated. We do have people on the back end to send nudges. And we found that after 1 month of use, for both patient and caregiver, their foot care knowledge have increased significantly. We also found that for patient, they are able to engage in more behavioral to care of their feet. So significant improvement in their ability to look after the feet. And for caregiver, we also saw trends towards improvement on caregiver burden. So even for 1 month, within 40 participants, we can see significant changes using the app. And from a focus group, there's a lot of experiential narrative that help us understand what part of the app is actually helpful. So from one patient who's 45-year-old, she said that the other changes that I really notice about myself is when I'm going to work and I know that I'm about to put on that shoe, then I have to rethink again. Do I wear open top shoes or slippers? Then I realize I can't do this. If anything happens, my feet will be in danger. So this app helped me to make a conscious decision in terms of what type of footwear that I use. And for caregiver, one of them says that I pay more attention to my mother's medication because now they're entering medication into the app itself for a reminder. I'm more mindful of names of the medication, the dosage, and how it makes her feel. I'm always asking her nowadays, so you take this medication at this dosage, how does it make you feel? So there's opportunity for dialogue and more open communication between patient and caregiver that enhances mutuality and enhances behavior change. So where do we go from here? Well, WellFeed is now in a stage whereby we are developing a technology disclosure. We have investor that has called us and really want to invest in this app because they see the potential, how it can be applied in big pharma, it could potentially apply to other healthcare institutions. So we didn't stop there. We went on and go back one slide. So we went on and based on the WellFeed technology and the knowledge that we have, we then took on a new project from what's called Cadence, which is Cardiovascular Disease National Collaborative Enterprise. And one of the work packages is to use technology to help patients who are at risk of cardiovascular disease to take the medication. As we heard all morning, patients are not taking medication, no matter how effective they are. You can spend billions of dollars creating a pill that is highly effective. If they're sitting on the table, it's a dead object. It doesn't work. You need the patient to actually take the medication. And so we are planning to develop AI as well as human health coaches to help patients take the medication, engage in positive behavior changes using the WellFeed platform to add on top of it. And we call this Cadence Diva, Digital Personal Health Assistant. Diva for short, Diva pun intended. And so what do Cadence Diva comprises of? We know that AI and app can be very helpful, but for it to be sticky, it's going to be very challenging because the novelty of a new app can wear off within a week or a few months. And after that, what sustains people's behavior engagement? And so we need to think of a more creative way because oftentimes people find sustainable engagement is related to relationship. If you think of counseling, 70% of what makes counseling work is not the type of tool that you're providing, it's actually a therapeutic alliance, is whether the patient trusts the psychologist, whether there is a rapport, whether there is a good relationship, so that if I give you a dose of CBT, you actually go back and do it and not just listen and don't take it on, right? So having that human element into in conjunction with AI technology can be one way forward. And so we call this human AI symbiosis. And so what we do is that on the first time that we introduce patients to this Cadence Diva program, we actually have a real human coach to onboard them, to engage them in motivational interviewing, to see what is their need, what is their aspiration towards health. And then we help them set SMART goals in that in-person setting. And all of this information is done through the app, it's done virtually, it's done through the app itself, whereby the patient is calling and voice calling the health coach, and all the conversation between the patient and the health coach is actually documented, transcribed, and used for further analysis. And after that first session, then the health coach inform the patient and say, hey, there's all these things that you can do. So we use the same methods in terms of developing WellFeed to develop the same sets of 1-minute bite-sized video to talk about cholesterol, to talk about cardiovascular disease risk, how to engage in healthier behavior, how do you communicate with your caregiver and loved one so that health behavior can be improved. And as patient learn and engage in the app, all the click level data are being collected. And then as the week progressed and time progressed, in the app itself, apart from education, we also have built-in sleep and step tracker. We also built in health gratitude reflective journals. So we have weekly reflective journal for patients to write a document about their health, what they appreciate their health is, and how can they make better changes to have better heart health. And all of this, again, is recorded and analyzed for the further information for the app to improve itself. And we also built in mindfulness self-care meditation. So there's a holistic regime of intervention that can be provided for the patient. And if they do engage in this, we will know. And the health coach is supported by a 24-hour access to an evidence-based AI chatbot that uses language modeling. And so after the first coaching session, the patient engaged with the app and learned from the app and participate in all these activities and interventional component. And every week, the health coach would connect with the patient on a text basis to review their goals. How have you been doing? Is there any challenges that you faced? What type of advice or information can I provide for you on a weekly basis? Then that process takes about 10 to 15 minutes. So it's effective, efficient, and it doesn't require a lot of time. And then every month, for at least the first 6 months, we have another live virtual session of the health coach to review the goals, to understand what are the inspiring moments that they have in terms of their heart health, and therefore renewal of goals and new goals. And when all of these things are being conducted through the apps, real-time analytics are being tracked. So click-level data, behavioral data, conversation, narrative data are there to inform precision health coaching. So when the health coach is seeing the patient in that 10-minute text duration or that 45-minute virtual session, there's no need for me to beat around the bushes. Looking at the information and the generative profile of the patient, I know exactly where this patient is. I know what they have learned, what they know, what they don't know, what type of behavior have they engaged in, and then my intervention can be much more precise that way. And so right now, in 2 weeks' time, we're about to launch an RCT with 450 patients to be recruited from the community to get them to use Cadence Diva for a year to see if their medication adherence has improved, to see if the cholesterol level have decreased, and whether they're engaged in active, healthy behavior. I think this is a way for us to understand how adaptive learning is being done. So in the very beginning, we create our set of educational content, and then we're using language model, we analyze the educational content, and then we develop pathways. So based on risk stratification, we develop pathway for people to get on, so it's more individualized. So this is pre-analysis. And as we registered a patient into the Cadence Diva program, we then put them on a learning path based on the risk stratification. And when the patient engaged with the app, we're collecting all this information, and learning analytics allow us to provide feedback to the patient. It then also helps us to adjust patient learning path if needed based on the existing learning pathway that we've created. It can also help us to inform whether new information, new content needs to be developed. And this provide further feedback for the patient. And at the end of a 6-week or 6 months duration of intervention, we can conduct a final assessment with the patient. And this type of dynamic analysis is done during the trial. And the AI is progressively improving itself. And at the end of the entire study, we capture and analyze the lessons learned, which then help us to recreate and redesign our educational content. In terms of the chatbot, what we do is we create based on the gigantic data set, we streamline it and we develop our own local corpus of information. And then we train the language model to be much more fine-tuned in terms of labeling and the categorizing of information. And when the patient actually asks the chatbot information, they will then see where the AI is actually looking for information within the domain-specific corpus, providing response. And this will then help us to further fine-tune the technology and also allow us to incorporate other levels of data to conduct retrieval augmented generation. So I think one of the key things that we want to talk about today is to ask about the bottleneck. So there's a few questions that I came up with. So I think more immediately is how can we apply and translate digital phenotyping data, risk stratification data, and risk prediction algorithm in the development of precise digital therapeutics that can effectively promote health literacy and sustainable behavioral change. Like, we just don't want a patient to use this for 1 month and then that's it. We spent millions of dollars creating this, and it's only lasts like a shelf life of a few weeks. Another question that we have is that, I'm not part of any of the major public health institutions. I'm not NXG, I'm not Sig Health. I have no access to their source code. I can't build an app based on their system. And so the question is, how do we integrate this digital therapeutic into the public or major institutional platform? And the final question is, if we are not integrating it and it's going to be commercialized, how can we create a efficient commercialization protocol that is founded on the principle of fairness, equity, as well as the spirit of collaboration for the greater good. And people don't want to talk about this, but once you get to that stage, you realize how challenging it is. How much controversy things could emerge just by looking at how much sharing ratio we should have. That conversation can be 6 months, and then the investor is gone. Yeah. So those are questions we can think about.
Thank you, Prof. Andy. So for the last speaker in the first session, we are delighted to have with us Professor Michael Meaney from A-Star to talk about maternal health. Welcome.
Okay. Now, to advance, can I just ask you? I can. Fantastic. Can you hear me?
No,
Great.
use the mic. Yes.
Well, can you hear me in the back? No?
I think we
We
need it for the Zoom.
record.
Need it for the online.
Recording.
Yeah.
Okay, there we are. You get the voice, I'm afraid. So sitting in the back isn't going to spare you. Okay, I'm going to talk about something a little bit different here.
Not right.
Sorry?
No,
The wrong slide.
Wrong slides.
Well, anyway, this isn't slide determinant. First of all, in somewhat in contrast to these talks, the wonderful talks you've heard thus far, I'm not talking about population health management. I'm actually going to talk to you about the work of two of my colleagues, Michelle Key, sitting in the back, and Sharon Liu, who is at IMH and NUS, in the development of what is a pipeline for the source of treatment distributed across the population. So we're not talking about enhancing existing treatments, we're talking about developing a treatment pipeline. Okay? That's number one. And number two is I'm representing Michelle and Sharon primarily in this particular exercise. So what we're talking about is maternal mental health. I'm going to try to get through this short enough to leave lots of time for comments and questions. But I can tell you that essentially Michelle is front-ending all of this, looking at the prevalence of maternal mental health across the population within Singapore. And another footnote to all of this is that state-of-the-art knowledge internationally comes from Singapore. Okay, so we lead in terms of our understanding of this as a population health problem, and we lead in many ways in the development of pipelines and treatments. So everything I'm about to tell you is dependent on local knowledge. So next slide, please. And that would be the next slide. There we go. So essentially what we're talking about, first of all, is risk detection. So we're looking across the population of maternal mental health. I'll tell you about frequency and prevalence in a moment. But the first thing, obviously, in trying to create a pipeline for treatment is to be able to detect who is essentially at risk. And Michelle has led this using largely a series built on Gusto. So she's trained a predictive model using data from the Gusto cohort, and then tested and validated that on as many as 7 different other cohorts across Singapore, Canada, the UK, right? And yes. And so essentially, when you look at this, what you find, next slide, and the next slide, since this is fairly simple, this just refers to the cost of maternal mental health. You know it's important. But first thing is the prevalence, okay? The prevalence in Singapore for mothers, right, women during pregnancy with a form of maternal depression that is sufficiently severe to impair their own psychosocial functioning, to influence the quality of their interactions with children, and thus downstream to increase child outcome, is 40%. Okay, so that includes about 10 to 12% of women who are diagnosable for peripartum depression, which is a statistic comparable to that in Australia, in Canada, the United States, Britain, etc. But it also includes a population in orange of women who are in the sub-threshold clinical range. And as I mentioned, studies, particularly at the National Institutes of Health in the United States, show that those women are just as affected, again, in terms of their psychosocial function, their parenting, and child interactions and child outcomes. So in essence, we're talking about 40% of the population. There are 36,000 births approximately in Singapore each year. You're talking about 14,000 women who would benefit from an intervention to improve the quality of their mental health. 14,000, slightly beyond the capacity of our traditional care, right? So this requires an entirely different pipeline. Next slide, please. And the next slide. So the other point to this is the timing of it all. You've probably heard the term postpartum depression. Take it out of your vocabulary. Okay, virtually all instances of clinical or subclinical depression are diagnosable in the prenatal phase, in the first trimester of pregnancy. In fact, Michelle's data, again, unique to Singapore, has actually shown that 2/3 of the women who have subclinical or clinical levels of depression during pregnancy were there before conception. Okay, so this is really a women's health problem, right? So it makes it even more imposing to be able to diagnose and detect risk. Next slide, please. And the next one. And the other component to this, by the way, is that, and this is kind of an asterisk that we can get to in a conversation, but for the most part, the existing literature up until the time of the Gusto cohort focused almost uniquely on so-called negative states of mental health, right? So that how does a mother's symptoms of depression or anxiety influence her well-being, her interactions with her child, and child outcomes? What has been discovered in the context of the Gusto cohort is that it isn't simply the presence of these symptoms, it's the absence of a more positive state of mental health. And you might say, well, that's just the other side of the coin. It's not. The two are not nearly as well correlated as you might assume. Positive mental health is quite different. And actually, even as I'll show you in a moment, has slightly different determinants. So in fact, the challenge isn't simply to deliver all of this to so many different mothers, but it's to emphasize not merely on symptoms of depression and anxiety, but to also start to think of how we can enhance the quality of mental health. Next slide, please. You can't see this in any case, but this gets to the training model, and here's the outcomes. So what Michelle and her team have done is to take, first of all, the Gusto data, and then to show what are, using machine learning, what are factors that determine, that best predict the risk for symptoms of depression or anxiety. And none of this is really going to surprise you too much. The top one, sleep, okay? How well you sleep, right, is the predictor. Now, we used to sit around clinically and think, well, sleep is downstream of depression. First, you get depressed and anxious, and then that disrupts your sleep. Truth is, the literature suggests it's quite different. that actually sleep is really at the front end of depressive problems. Reactivity. Individuals who are simply more responsive to the nasty things that are occurring, the slings and arrows of everyday life. Social support, hugely important. What's the quality of the individual social support? And particularly, of course, with the family, the friendships, etc., that they face. And then another component to this is childhood experience. Individuals who came from a less nurturing family life are more likely to experience these particular factors. And here you just see the weightings to these particular factors in terms of their ability to define a risk. Next slide, please. And this just shows you that that model can then be replicated using either Singaporean cohorts or those internationally. In this particular case, the MOHT cohort is a Canadian cohort. What you see is the area under the curve. It's about 0.75 to 0.8 in terms of prediction, so it's pretty good. Next slide, please. If you start to then look at positive mental health, you find slightly different weightings to these, many of the same factors. What you see in particular in the blue is the social component. So the social component is obviously essential for offsetting the states of depression and anxiety. It's also critical in terms of enhancing positive mental health as well. Next slide, please. And this model again. So now what do you do? Okay, you have 14,000 women. You're trying to target not only symptoms of depression and anxiety, you're also trying to target positive mental health states as well. Now, let me make one really important point in terms of the development of this pipeline. We understand, right, fully that there are severe cases of maternal mental health problems, notably psychotic depression, right, that are well beyond the scope of what we're talking about here. Right, so every year, I think IMH sees about 150 to 200 women who are featuring extraordinarily severe cases, bipolar disorder, psychotic depression, etc. This is not our particular target, right? At the very best, this would be an adjunct. This pipeline is intended, however, to be the primary go-to for those individuals not receiving such level of traditional care. So the first thing is risk detection. I mentioned that to you in terms of what Michelle has put together. So we have a model that is reasonably accurate at being able to detect those women, all the more important because there is such a prevalent preconceptual state that needs to be taken into consideration. So now I want to talk to you about the work that's pioneered primarily by Sharon Liu at IMH and NUS, and her husband, Jeffrey Tan, who's at IMH. So this is essentially using internet-based CBT. Sharon is a student of Nick Tickhoff's at Australia, an expert at internet modeling of CBT, which has been shown, as you heard, I think just in the previous talk, to be effective with respect to mild to moderate cases of mental health disorders, particularly depression and anxiety. So first thing that occurs is what Sharon has built is computerized adaptive testing. That's basically clinical phenotype, right? What are the primary features of the individual? What are their vulnerability factors, right? What makes them vulnerable and effective and affected in terms of these mental health states? And then the second component is then to tailor the internet CBT through various modules. There are 8 different modules in the package that Sharon and Jeffrey have developed, is to tailor them to the vulnerability factors, right? So you have basically a chat bot that is matching individual vulnerability factors to the ICBT. Now, the other component to this, right, is the notion of looking at the motivation of the individual and their ability. You've heard all about compliance and issues like that. So there's a wonderful old joke that I tell the residents. How many psychiatrists does it take to change a light bulb? Raise your hand. Only one, but the light bulb really has to want to change. Yes, it's a joke, but of course you deal with psychotherapy. You know exactly what I'm talking about, and not just psychotherapy. So the point is that you can then tailor the motivation. That's a very judgmental term, but so it goes. And often this refers to the burden that the individual patient is living under and whether or not they are then candidates for a full ICBT, the 8-week program, or an Ultra B program that is currently in development. And then finally is the notion that, again, you heard repeatedly, particularly in the last talk, is about psychoeducational content. So that's the pipeline. Now, the question young Lee asked is, how can AI enhance this pipeline? So the first is to link the risk factors to the computerized adaptive testing, the individual factors. So for example, Michelle's team has identified a whole series of factors, and collectively they predict the risk for symptoms of anxiety, depression, or the absence of positive mental health. But they don't do so in the absence of linking up with vulnerability factors. So what we need to know is, how do we link the risk detection to the vulnerability factors, which would of course mean that you could then take screening and computerized adaptive testing and put it into a single package. Next slide, please. Feature detection. This is really interesting. And if you're interested at all in mental health, Ken Kendler wrote this spectacularly interesting synopsis in the American Journal of Psychiatry. He read 15 books on depression, beginning from the Greek philosophers. What do people think about depression? And for the most part, every one of the 15 dieties basically identified the same things that we use today in diagnosis. But they mention two things that we don't use. The first one is facial expressions. The second one is the language, right? The intonation in speech, but also the content of the language as well. And those are features that are well known to really associate in much the same way as you heard from Robert and the others using the digital phenotyping. So these can be captured in feature detection. And so in essence, for example, then you could use both facial expression and language in the context of an interaction with the individual. And so again, move beyond this laborious number of questionnaires that need to be assessed for accurate risk detection and bring this to a far speedier conclusion. The other component to this is basically the assumption. I mean, we often do efficacy outcomes, right? We say, did it work or did it not work? What we don't do is ever ask the question, what did work and for whom, right? And so essentially what we also want to do is to try to get into this, look at the relationship of the vulnerability model, of the vulnerability factors to what components are actually working. We think we know, but that in 25 cents gets you a straight times. So finally is the issue of psychoeducational content. So Sharon courageously scans the literature. Again, you heard about this in the previous talk. There are search engines by which the content here could in fact be expedited. It could be more timely. It can be screened for being more evidence-based, etc. And so again, these are all the individual components. So young Lee, you asked the question, how could AI enhance this pipeline? There's at least 4 thoughts. Thank you very much. Yes. Yes, okay. But not all at once. Yes.
So you were talking originally about maternal health.
Yeah.
And one of the things you brought up is feature detection. So talking about, for example, intonation, types of language, and facial expressions.
Yeah.
Are you actively utilizing that data to get a better understanding, like using phenotyping to get a better understanding of maternal health?
Yeah, that's largely aspirational at this point. We do have one project which is being embedded in Gusto to look at adolescent mental health. And so we have face-to-face structured events. So we, first of all, ask the individual to describe an event that made them very sad and feel bad, 3 minutes. Second, after a little clearance, washout as it were, they then ask to describe an event that made them feel very pleasant. And that's being done in the adolescent component. This is aspirational at this particular time, highly doable, really. Yeah.
I think one of the points you brought up between, does it work or doesn't work, and if it works for who, if we can disentangle that, we can also kind of tease apart why the things don't.
Oh, that's, you know what, you hit on something that I've been thinking about over the course of all of this. You're absolutely right. I mean, for example, I mean, this is a little bit off tangent, but it gets to the same point, is we heard a lot about patients not taking medications, and I was going to ask Andy Ho that with that wonderful interactive data that you're collecting, you presumably are able to say what are the primary factors, the obstacles, etc. And this would be much the same way as why does it not work? Is it because of individual characteristics? Is it contextual, etc.? No, I think that's absolutely the case. And my suspicion is, yeah, there'll be the individual components where we could tailor, but there's going to be a contextual dynamic here as well. Family environment, the burden, etc. I mean, for example, we know already, going back to the Head Start, that you can describe and put in place the very best treatment options for children. But if you do not address parental mental health and family dynamics, nothing works, right? So the context itself becomes something that c'est compliqué. Yeah.
Can I borrow the?
Yes, by all means.
Just to comment on that language and speech and facial features, that there was a big workshop at the last AAAI conference in February on mental health, AI and mental health, and 60, 70 people and maybe 40 projects. 2/3 of them are on that. Only 1/3 are on what you heard us describe, phones, wrist, etc. I would say in general, the speech and the language, it's not just speech, it's also language, because a lot of counseling by text is not as accurate as the phenotyping on phone and wrist, but it's very complementary, meaning if you can put it all together, you get even much more. But I had different question and comment for both Michael and Andy, which is this, which you both talked about, particularly Andy talked about the monitoring and the hand-holding during the process with human contact. And I think this whole idea of forming a therapeutic alliance or empathy with a bot, a purely mechanistic bot, is very questionable. It's been reported on in the AIRS paper in JAMA that their empathy can be high, but it's very artificial. And in many cases, it's it doesn't create trust, and because it's not a real human, people won't pay attention to it. So one of the things we find again and again, we're finding in our work on HOPES and also AMI HOPE, and also the US versions of AMI HOPE, which have come before us, which is post-discharge counseling for behavior change. A big part of it is the fact that there's a person over there that I'm connected with. And I think it's the same in ICBT, that fall off is greatly reduced if you have human monitoring and coaching. And there's also this Hawthorne effect that a lot of patients feel that, you know, in my diabetes recovery or my hypertension recovery, I don't want to, like that nice nurse that I see when I go in every 3 months. I mean, she's kind of watching. She's seeing me, and when I start smoking again or my sugars are up, she's noticing, and I better do the thing because there's this human. Don't want to disappoint her. And so you form this alliance with a person, even though maybe they're just glancing at your data once every 3 months. You can form an alliance with them. And of course, much better in the ICBT. So I think that's something we have to figure out a way to create or substitute for that. I don't know if you have any thoughts on that.
Yeah, no, you're absolutely.
The human, because, you know, we trust humans. We don't really, it's very hard to build trust with a machine.
No, you're absolutely right, I'm sure. And you alluded to exactly the same knowledge base, is that therapist-assisted ICBT is infinitely more successful. You know this, Robert, from your pioneering work with MindLine and WISA. So the therapist-assisted component is absolutely essential. In fact, a dirty little trick in therapy is that when you have a patient who you fear may be suicidal, is that you really emphasize the bond. You have no idea how many patients have not committed suicide because they don't want to dishearten, disrupt, and break the heart of their attending physician. Yeah, no, it's absolutely essential. Anyway, Andy, I don't know if you want to. But you're absolutely right.
Yeah, these are really important topic, and I think when we first proposed the idea of human AI symbiosis to SAB, they were thinking, well, how the human element is going to play into this. And we did a series of systematic review, or just systematic reviewing the literature, and to find if there's any actual study that looks into the sensitivity of how human is actually engaged in these type of apps. And surprisingly, there isn't a lot of study that's being done. And in terms of how the human is engaging and what role do they play is unclear. So for Cadence Diva, while we're developing this, we're also trying to understand the level of engagement. How often does the coach needs to be connected to the patient? What type of conversation needs to take place? Can it be shortened? As the AI chatbot become more intelligent, can they replace more of the role that the human plays? So we're also testing and understanding that from the study.
Sure. You can even start to look at the nature of the therapist. Is it a peer, same gender, etc.? Absolutely, absolutely. But things you know, Robert.
Yeah.
Yep. Yep.
Any other questions? Back.
Hi, my name is Sean, and my question is in the context of emergence of ChatGPT 4.0 and whether are we behind the curve? Because a lot of this development, as I can see, and of course, I understand the concern whether is this another person that we're speaking to. As I reflect a lot of this, some of the hotlines, whether sometimes you have this mental distress, you can have this care hotline you can speak to. Actually, I do not know whether am I speaking to an AI on the opposite side or a real person on the other side. And especially a lot of call centers these days, whether for IT issues, when you're speaking to another person on the other side, you also do not know whether it's a real person, whether it's in Singapore or from another country, or even is it an AI. But I'm just wondering whether a lot of this algorithm technology in what we are developing, are we still quite behind the curve when there's all this emergence moving on very, very fast? And I'm seeing very promising results when the ChatGPT 4.0 is actually really real and can actually be providing counseling to the other person. So I'm just wanted to get some perspective on this from the expert.
No, the efficacy studies remain to be done, to be honest. Robert and I and Michelle and others have worked with WISA, which is probably, WISA, by the way, is the, with the largest market share as internet for depression, by far. And efficacy there is not great, overall. And that's even focusing, as they wisely do, on mild to moderate cases. So no, we're not behind the curve. And the other component is that I would argue that a lot of what's being developed is being developed without a sufficient knowledge base. So for example, this issue I mentioned to you right at the beginning with AI, what is the relationship between the risk factors and the individual vulnerability factors? That's core, absolutely core to being able to go from screening to bringing people into an intervention space. The ethics knowing about that. So no, I think there's a lot of hype that you hear, to be perfectly frank, and an enormous, it doesn't come, by the way, from WISA. There are a number of people who are very somber about where they are in knowledge space, but no, we're not by any means. And I think unless you marry the technology development to really strong domain expertise, you're running way ahead of the curve and you're basically irrelevant for the most part. And I think what was strong about almost every one of the talks you heard today is that you don't see that, right? What you see is clear appreciation of what are the constraints, what are the limitations, etc. I'm really, no, I'm not in the least bit. I think the technology development we love. I mean, it's clearly neither the domain of Sharon, myself, or Michelle, certainly not me. But no, we're not behind the curve, not at all. And I think the thing, again, to come back to this is make sure that the AI, the databases, and the domain expertise are in the same room. That's absolutely essential. And I think for much of what you're seeing in terms of the various chats that are out there, they're not impressing.
Mike, can I?
Yep.
Yeah, so quick question on that. Like WISA, which is in Mindline, has a lot of users in Singapore. It's actually, it's okay. It's helpful to some people like it. It's not bad, helps some people. And the best thing it does is it directs you to a sleep exercise or account. That's the best thing that it does. It also directs you to crisis, and it also gives you some basic, it's got like a whole bunch of sleep exercise. It's got a lot of stuff, but it's far from perfect. And you could rate it good. Maybe it's a B- or something. Now you compare it with ChatGPT. ChatGPT is actually pretty good in terms of and we've compared it. And we're in discussions with the founders at Wiser, and they're very, very focused on enhancing their product. It's also, so it may even be better on the average than Wiser, just a pure ChatGPT 4.0, but it's worse on the tails. And there are terrible stories about bots turned loose. There was a case in, I think it was Belgium, where somebody got some advice, was suicidal, got some advice, and the bot, after many exchanges, the bot ended up agreeing with him that it might not be a bad idea. He committed suicide, but he did commit suicide as a result of that. That bot is no longer operating. But it's on the tails. It's very much like self-driving cars. Better than humans on the average, but worse and very, very concerning on the tails and who's going to take responsibility for that. So it's an early stage, but it's moving very fast. And one of the things we are doing, we're not going to talk about it today, but Ono is here, who's working on this. Yisheng is on the line. We're doing dual dialogue systems, which means the AI is advising the therapist what to say, because sometimes the therapist will have 3 or 4 customers on or clients on the link. They might not be able to keep track of all their backgrounds or their history, what they've already said. And the AI, at least the thing it does it very well, it finds resources in the 500 odd resources that we have. It suggests the resource. The therapist, or sorry, the call taker, who may not be a fully qualified therapist, but has some degree of qualification, gets constant suggestions. You know, you could give them this, you could, and they take it or leave it, right? So it's a much lower risk where you have this dual dialogue. You got a buddy window for the therapist giving suggestions, things they might not have thought of, or resources that they shouldn't have to search for the link for that resource. So that dual dialogue system is very powerful, and we kind of mentioned that. We won't discuss it today. But when will these ChatGPTs get to end it? Some people think they will. We're not convinced that they will, and we are not willing to take the risk at the moment. But things are moving forward very fast, and it bears watching, and it should be the subject, like that very like outrageous slide that I had on the Go analogy. And can we get these things to learn new methods? Can we get these things to be really good assistants? Can they be under supervision? Can they be, and one of the most fun things is now going on, people are putting these bots together into little groups and letting them interact together and seeing what kind of societal behaviors occur. And there's some weird behaviors that start to occur when you do that, by the way.
Same thing happens with patients, actually.
Same thing happens with patients, yeah. Yeah, so.
Yeah. Thank you, Robert. That's, yeah. I'm going to make one last point, which is a little off orthogonal, but it gets to, because the talks you've heard so far have all dealt with case management, population health management. When you come to rolling out interventions across the population, right? So I think, for example, with the HPV interact of increasing physical activity, it's essential to have this risk component built in, right? Because you can turn around and say, well, overall, I increased people's physical activity by 10%, but in what component of the population did that actually occur? Yeah. Right? Because inevitably what you often see is that those people, they went from 4,600 steps to 6,800 steps, but the people who were 12 steps, right, and the high-risk population, that is not necessarily. So on the population level, that's another reason why I think that these kind of things need to be cooperative. We really need to know in whom we're making these kind of changes, to come back to your point. That's a shot my rock. Nothing else to touch.
And any questions on for any of the speakers or in any topics? I think before we move on.
Can we thank Professor Michael Meaney?
Thank you.
So I think it's good we have a 10-minute break, but for coffee. The last slide. Yeah, so this is a list that we put together according to your selection on the breakouts that you were interested in. So I would suggest we have a 10-minute break, and then when you get your coffee, you can go to the respective tables. But feel free to say this is not set in stone. You're free to move around the tables for discussions as well. Okay, thank you.
We're supposed to go to the tables.
Copy again.
Copy and then back.
I'm glad that this is an informal setting. I know I wear a tie and people say I look very formal because doctors have stopped wearing ties for infection control reasons. But I see psychiatric patients with mental disorders and infection control until they prove that infection is the cause of mental illness. I will continue to wear my tie as a way that I work with patients. Just a short of introduction, a little bit about myself. I'm a child psychiatrist, so I work with kids. And my experience with kids come in twofold. One with the patients that I've seen in the last 30 years, and the other is, of course, with my own family, where I have 5. And I was just remarking to Michael Meaney just now, he's gone off, that soon I will be the grandfather of 5 children under 5. Right, very soon. Now it's actually officially 4, but because we do consider the antenatal period as counting chickens before they hatch, I have 5 grandchildren, all right? Think as you like what that means. Okay, so today I've prefaced a 15-minute talk on this concept of the Cinderella of medicine. Why do I say this? Psychiatry is often called the Cinderella of medicine because it's often forgotten, like the beautiful princess who was, because of the stepmother has put her to do work at home, where the stepsisters have taken over. But the Cinderella of medicine also backs the 2 stories that I'm going to talk about: the pumpkin and the slipper, or the glass shoe, or whatever you call it. Because in the Cinderella story, if you're familiar, and I hope all of you are familiar with Cinderella, I don't know, maybe this generation, nobody's heard of Cinderella. Cinderella's story is about, Cinderella getting a chance to go and meet the prince at the ball. And that was such an opportunity, but the stepmother had created many barriers and stumbling blocks, but she still managed to go with the help of the fairy godmother. Now, the fairy godmother in our story, and I'm using this as a metaphor for what I'm going to talk about, is of course funding for research. And with the fairy godmother's help, Cinderella managed to transform herself right into a beautiful princess who could then attend the ball. And she had, of course, on a beautiful garb and glass slippers. At the same time, the fairy godmother managed to convert the pumpkin into a beautiful carriage to carry her to the ball. Unfortunately, this magic only lasts until 12 midnight, which is usually funding resources have a limited time, But what is interesting about this story is that at 12 midnight, as Princess Cinderella was running away to get back home so that she would not be caught, 2 things happened. The pumpkin reverted back the carriage reverted back to the pumpkin, but she left behind the glass slipper, which continued to be there while she had one pair with her, pair with her. And eventually, of course, the glass slipper allowed her to be reunited with the prince that she loves. And the same thing with research in mental health. We would like to think that we're not the pumpkin that gets the funding, and then at the end of the funding, we have no product for it, but the product is the glass slipper. And this metaphor, by the way, is Robert's suggestion. I modified it a little bit about why it is important that we find the glass slipper. So today I'm going to tell you about how to find this glass slipper, and hopefully we get a chance. Okay, it is a bit slow. You're right. Let me just press this again. I decided not to move. Okay. Maybe you can move the slides from next slide. Yeah. Okay. Okay, so what is the state of mental health in Singapore? The last epidemiological survey, a large-scale survey, was done in 2016. 1 in 7 persons have a lifetime risk of developing mental illness. Now, what's more important is mental illness is a disorder of the young. So the burden is highest in the younger age groups. Now, this slide's a bit small for you to see from back there, but to trust my word for it, this blue line, blue patch here is mental disorders. And you can see the squares that are outlined. These are areas, percentage of years of life lost to disability. So mental illnesses generally don't kill you unless you kill yourself, right? That's one way that you die from mental illness, but it does create a significant number of disability years, which in this chart, you can see, this was a study in 2017, about 20%, which is quite significant, of the total years lost to disability. Next slide. I'll just tell you next slide, because this doesn't seem good. Okay, the other thing that is that I like to talk a little bit about is there is a crisis in mental health. And like Cinderella, she's now placed in the kitchen and she has to do a lot of work. There is increasing prevalence. Now, this is controversial. Overall, I think prevalence of mental illness hasn't really increased, but there is a perception. So in Singapore, people think that there's more mental health problems. So this was a survey done in Singapore. But there is a group that specifically has shown definite rises, especially after the pandemic, which is the young. So I think there is an increasing prevalence of mental disorders in the young. The second, of course, is there's an increased demand for services. Whether you are actually having a mental illness or not, there is a need. And this is a study in the US. People felt that they really needed to go and see someone to get help for their mental health issues, which could be distress. Doesn't necessarily illness itself, but they need to be evaluated. And then there's a shortage of resources. If everyone went to the psychiatrist, this is the US projection of how many psychiatrists they need and how many they actually will produce through the system. Now in Singapore, we are far off from there. Singapore is even below the WHO recommendation of 10 psychiatrists per 100,000 population. In Singapore, we only have about 4.6. This is an older data, so it's just 4.2. And we also don't have psychiatric beds. IMH is the only hospital that says, okay, we're full, but we can't send anywhere else because we only have one hospital. More than 90% of the beds for psychiatry are in our hospital. And that's very sad. But that's something that we have to think about. I hope the new government will consider building up resources that way. But the important thing is we don't have enough psychiatrists. And even if we produce up to 10 per 100,000, when we will reach nearly Japan's level, it will take 10 years or more. So no resources, increasing demand. What can we do? Who will be our fairy godmother for psychiatry? Well, there's an interagency task force on mental health and well-being, which has come up, and I'm sure you can go and read it. It's on MOH website. Talks about the tiered care model. So the tiered care model is basically a stratified model or step care, as typically described. It is not known to be super successful for a few reasons, but we still want this model because otherwise we can't segregate, place patients and non-patients on different aspects of it and provide care. But the problem with this model is that if you don't resource enough, the model will fail. So step care models have been tried throughout the world, but it's one consideration. Now, one part of the steps 3 and 4 are the illness side of the house. And step 4, tier 4 is the highest level. So tertiary care, where you often would require psychiatrists and multidisciplinary teams. There's also a recovery phase when after you get the tertiary care, you need to continue to monitor, especially for chronic mental illnesses, for example, schizophrenia, high intensive burden disease. And this, in this instance, a mix of professionals is needed. And then finally, there's population health. This is the group that many of us are on, although 1 in 7, this is a good, nice, normal distribution of stuff of people. One of you may have a mental illness. Maybe you have a mild illness, then you will enter tier 3. You might not need tertiary care, but you certainly need some kind of care in the community or in community specialist resources, where you have a mixture of community as well as non-mental health resources being applied to you. Underneath all of this is really enablers that allows all of this care, whether it's tertiary, recovery, or population health, to get help. And I put it in 3 main areas. I think that the fairy godmother's magic works these 3 areas today. Okay, that's my sense of it. Digital mental health, because there's the ability to scale, and that includes health initiatives. AI, because there's a use for it in predicting and also identifying high-risk groups, particularly in large populations. And then finally, what I call serious resources. These are resources that don't come up as mental health resources, but they have secondary, like for example, if you're watching a movie, the movie teaches you about mental health and improves your literacy on mental health, that could be a serious resource, right? That's one example. It could be a book, it could be a game. So with that, I'm going to say 3 challenges that such as a tiered care system has. One is that, can we provide treatment without clinics? There's a lot of talk about self-treatment, self-care, self-training, and there needs to be an ability to do that, but be able to cascade that skill. This is just an example that we have where you can train attention. It is a Singapore company called Neuro that uses EEG signals as a computer feed-forward mechanism for trying to train a brain-computer interface, a person to be more attentive. Now, this doesn't necessarily mean that it is the traditional treatment, but we've proven that it works. The second is hospital without beds. This has been talked about for a long time, since 2018, the concept that there are virtual hospitals. And the fact that you can actually, find the best service virtually, whether it's a psychiatrist or online service, even insurance and so forth. It says, create an account, schedule an appointment, feel better. This is, of course, in the US, but it's conceptual. Then, I wrote this paper some years ago, specifically on child psychiatry, but it talks a little bit about the step care model, where in the traditional model, where we have clinics, we have a huge treatment gap. It doesn't mean that today we've matched it, but what we've done is we created an ecosystem where there's tertiary care and early detection in the community at population health level for children. So we started this program called REACH. And this is a theoretical model, but the question is, can we get it applied, sustain it at scale? And of course, today, this is a New York Times op-ed, I think, that says, can AI treat mental illness? Maybe we're not there yet, but could they? Now, the last one, perhaps, is most, since you are all presumably researchers, if I were to propose to you, can you do research without researchers? And again, this concept is possible because this is a Lancet editorial, a Nature editorial, which talks about this. Can people sort of advocate and with the assistance or enablers in the digital space actually provide, help themselves do research and participate? So I'm not saying without research, but only not just researchers. Really, this is, for example, a research priority that the American Academy of Child and Adolescent Psychiatry has put up. And right at the center is the patient and their families. And so research needs to be collaborative. And again, you need to have a fairy godmother that can bring all of this together. So let's look at what we can possibly do. At the research level, and you're going to hear this later on in the afternoon, how can we discover some personalized markers for the health state, the unhealthy state, the well-being stage versus the distress versus the illness stage, and then adapt it to care settings. This would be very research-based. But say at the clinical level, can these interventions also be then turned around and provide smart responses to the patients and their families so that they have feedback on how they're doing? And so we have a bit of examples of what we've been doing, and we're going to hear a little bit after me about the use of AI and sensing and interventions in mental health. And I think it's important to see this across the ecosystem, whether it's in the clinical setting, whether in the research setting, and even in the wellness group, where we have in the tiers 1 and 2. I think it is important to understand that all of this is interconnected, and if the magic is really bringing this together for everyone, so that even if you're a lay person and you're out there, you can participate. I don't know how many of you do surveys. I do it a lot. Every time I'm sitting on a plane, I'm doing a survey. And I'm also obviously contributing information to the the airline or whatever commercial. Now imagine if this was health related. We have so much potential that we have not tapped today. So I won't go very much into this because I think Jimmy's going to talk a little bit about hopes. I just want to say that I've got one or two patients. Where's Jimmy? I got two patients that's on the program, and I get a lot of feedback as the clinician taking care of them, and it really helps me to see these patients. One of them has a serious mental, both of them have serious mental illness. One is a mood-related serious illness, and the other is schizophrenia. So the ability to sort of understand events, whether it's in their sleeping, and today the use of wearables is quite big. But the wearables we are familiar with is the watch. So I've got my Apple Watch. But you know what? When I sleep, I don't like to wear a watch. So maybe in the future, we'll have to think about other wearables, perhaps your ring. Okay, perhaps. That's one area that we could. But some people don't want to wear rings either. So are there other ways? But there are. And then if you are able to identify events, you can intervene and you can improve care. You can predict problems and you can get them to help earlier. So this is at the tier 3 and 4 level. Right? In the tier 1 and 2 levels, we can have some kind of automated system that could possibly help. And this is a chatbot concept, right? A chatbot that we've developed with 4 partners, MOHT, NCSS, and the Ministry of Social and Family Development. And the whole idea is that there a website with a chatbot that can help you through navigate the mental health ecosystem, which is quite complex in Singapore. And then, of course, the chatbot is based on an existing chatbot that has been validated for efficacy and functionality, and it's available all the time. But the key is really making it sort of AI-enabled and responsive to the individual. And I think the time for this magic to work is really now, because I think the language is understandable. People are using computers a lot more. The internet is widely accessed. And I think we've also developed this chatbot concept a little further with AI and this digital peer support forum, which is really drawing on peers and not just individuals suffering from illness. So peers could be, I mean, we use the term very broadly, could be people the same age, but peers could also be people who have suffered the illness and recovered from it. And if you imagine if you can draw from it. The old days, I used to have to organize a group meeting where all the persons will say depression would come together and they would share. Imagine you can do this virtually. It's very powerful. And they can help one another. And if there is a facilitator who's automated, but with AI, then you have the beginnings of the opportunity to do group support in counseling on the virtual world. And that's what Let's Talk is about. So this is just an example. For example, there's a problem here. What's the problem? Therapists often spend extensive time, up to an hour, creating empathic and useful responses. And what's the solution? Is this chatbot that gives you a lot of links and possibilities. And in the young generation, this is actually useful. Now, you can't do all of this digitally. I think there needs to be the third person available, but this is an opportunity really to extend and research on those possibilities. How do you make it such that you can't tell the difference between this and then subsequently someone actually physically supporting? So in Singapore, it's going to engage on a national helpline that IMH is going to do starting from January 2025. So we are hoping that that would be a platform for some of the work, the AI type work that we like to do. So beyond mental health, I think the key thing is about integration. In tiers 1 and 2 of this tiered level of care, a lot of it has to be integrated. So there's opportunities to integrate physical health. In fact, after this, I'm going off to another meeting where I'm going to talk about how we want to work with the physical health side of the house, that means general hospitals and physical health. And this is an example where integrated, say, a robot, a chatbot that does physical health can at the same time cover mental health. And you have the opportunities for Healthier SG, which starts in 2025 to include mental health in its sort of repertoire of tasks that GPs will actually go through with patients. So, just to remind us that this is not a fairy tale, even though I used the fairy tale as the metaphor. We hope that there's the slipper will be the one. I couldn't find a glass slipper, so this is a dark glass slipper. Who's the head of the pumpkin and will continue to drive the transformation that we're looking for. So this is to be continued. Thank you very much. Questions for Prof. So I have a question. This workshop is largely about AI. You described a few opportunities, a few things that are ongoing. But what else do you see? What gaps do you see in the long term that might be fillable? Of course, it will never replace the human touch. But what further support or what direction do you see from here to really help with the challenges that you started off in your talk? Like I said, I talked about the step care model as not necessarily successful. It has to do with resourcing. So most step care models around the world don't work because there isn't enough resources pumped in at tiers 1 or 2. I think AI can bridge that gap. I think it's important to think around those areas. Prototype. I don't expect us to do that 17 years from conception of idea and concept to basic science research and then actually changing practice. But what I'm suggesting is to evaluate programs and prototypes around using AI to see if you have an opportunity. That's what I see it between the tiers, between tiers 1 and 2. So from the general population without illness to an at-risk group, how would they transit? What are the differences? Would you be able to pick up the at-risk groups? And then from the at-risk groups to those who have mild illness, how do you get that help to them? And I think AI will match that, will allow us to reduce the number of resources we need, and therefore allow that work to be done. The sustainability of many of these projects, unfortunately, lies in staying in the research sphere, in universities. I've seen many interventions that seem to work, but it takes 10 years, and it's still not in full-scale utilization. So we need to think about what are the things that we can roll out in the community, evaluate those programs within 3 to 4 years, and then really scale for the country. And I think Singapore is a good place to start. Go ahead.
Thank you so much. My name is Jacqueline Mayer. I'm with the Singapore ETH Center. And we're developing a program that does just exactly what you said. My question to you is, though, is there space for additional solutions beyond WISA and MindWide, the solutions that you already have? And how can we maybe implement those with your support?
I think there's only one bite. Okay. There's always space. I think the problem with much of technology is interoperability, which I struggled with for a long time. I'm still asking, why wouldn't we just drive on the same side of the road and use the same plugs just for our PowerPoints? If the software companies can come together and work on single platforms, then the ability for even chatbots to chat with one another, because that's the important piece. If you develop something that works in a certain group, there is a place for 300,000 apps in healthcare. If those apps can talk to one another, the problem today is it doesn't. So maybe that's the problem that you have to think about. Is there common platforms they can get on to create that?
Just quick comment on that. So MindLine is a platform that already hosts 3 third-party tools. It hosts WISA, it hosts Intellect. We're about to announce a 3rd one. There's always room for more. And we want to be a general platform. We want to host, and we have a tremendous catchment. We've got over 1 million people coming into MindLine.
So yeah, absolutely. But before you run off to your other broader NHG meeting, we got the 20, we got it down pat, right? What about the 80? And what about the relationship between behavior and attitude and mental health and all those chronic diseases that are out there in the 80, including aging and loneliness and dementia? What about that? Ideally, of course, everyone should be their own doctors, that they should be taught instead of science. I'm sure numeracy and literacy is useful, is to teach you how to take care of your body right from the start. This is health literacy. And I think that's where we have not moved. Education, as we know today, is around learning basic science, maths, English. So should we know computer science? Should we include healthcare related topics? Doctor in Latin means to teach, and ultimately you're most responsible for your own bodies, your own mental health. If we can teach that early in school, actually there is. I mean, I've been involved in developing curriculum, but it's always a secondary piece, at least for mental health. It's the Cinderella of education, right? Why learn about them? I mean, all the kids today learn about the heart very well, but they don't know how to apply it to their lives. So maybe we should change. And that's where the conversations would probably exist in talking to the curriculum people in the Ministry of Education. Singapore actually has an ability to do this very easily because it's in schools. Everyone goes to school. The curriculum is centralized. It's controlled. You can't say, oh, this school teaches it differently. Almost the same as the South. Any other questions? Yes, in the back.
Hi, thanks. My name is Gali from Primary Care. I'm just asking, talking about the AI in mental health chatbot, how do we help the people in the other side of the digital divide? So we like, besides getting them to the other side of the digital divide.
I think here you have to think that the other side of the digital divide is what? My father is still alive. He's 92 years old. He sits down too much and he does only one thing. And then when that thing doesn't work, he calls me. It's called the television set. So you need to think about your solutions age dependent. So I would think, if you can have channels that make sense to older folks who are not digital savvy, it doesn't have to be digital the way we understand it. I think that the smartphone is only for a certain group of people. It's not for everyone. And you need a simple phone, but how do they use it? The television is something very, very common and ubiquitous. That could be the point for some of that. But they are still on the digital divide. They're just on that side that's fairly automated, that's responsive. And now with technology, wearables, or even sensing equipment, you can actually make it simpler. So I would imagine in the future, all television sets will come with cameras anyway. It's just a matter of time. I monitor my dad on a lot of digital technology that he's not aware of. He doesn't need to. There's a camera in the house. I check in on him, and that's some of the things that we have to think about. So I don't think we have to move them to what we are familiar with, but move what we're familiar with into that space that they're comfortable with.
Other questions? Can't let a child psychiatrist escape without the question about the social media, Jonathan Haidt's theory. That's why we have a 250% increase in suicide attempts amongst young women in the US. Jonathan outlines all kinds of ways it's disturbing the cognition of youth. And there are those who are just as convinced that it's not good. What's the answer?
I grew up in a time when we talked of banning video games and video game parlors. And there was a book written about computer addiction because there was fear of computers. I think social media is here to stay. The question is, do you want to end up in the kind of weird world that's the Black Mirror type story, or do you want to think about how social media can benefit. So I think that's where we probably want to embrace social media more positively. When I first started out as an administrator in the hospital, my top comms said, we're not getting into social media, it's bad. And yeah, everything has a trade-off. And social media has ability to bring people together, a forum of international capability in large groups. But large groups has the risk because you can, end up with lots of problems. I know that the minister himself, Minister of Health, feels that's the source of many of the problems. But I think we need to think about how to use it in a positive way. So I would not dismiss it because you can't get rid of it. I mean, US tries to sell, no more TikTok, right? Okay, I'm sure that TikTok will flourish, further. So I think the key is not to stop the technology, is to think about how to use the technology better.
Any other questions? That's been fantastic, very inspiring. Thanks so much for the invitation. Prof.
Thank you, Prof. So our next speaker is Dr. Jimmy Lee. Dr. Jimmy is a psychiatrist and senior consultant at the Institute of Mental Health. He is also chief for the North and Central region at the IMH as well. He is also a professor at the LKC School of Medicine. So we are very delighted to have Dr. Jimmy share with us about hopes.
Will you be moving the slides for me?
Yeah. Thanks, Yang. Hi, good afternoon. So it's a hard act to follow up on the boss and done something like that. So I'm here to share about Project Hope, which I think throughout the whole morning, of course, you've heard actually a lot of it already, so I can skip through it quite fast. Now, I'll start off this picture. Project Hope is not just one person kind of endeavor. This is actually really a multidisciplinary endeavor. And it's gone on for 5 years, since pre-COVID, right? We just said to get an era. The next slide. Okay, great. So how do we get here? So earlier in my group just now, just sharing about some of the problems we face in healthcare today. So unless you have a pain, you have a healthcare concern, you never see a doctor. If you see a doctor, is bad news. LTSG is trying to change that, but I have my doubts whether or not anybody will see a doctor for good things, right? And this is really the issue also behind mental health. And we add on to that our workload that we have. What we try to do then in clinical practice is actually try to defer and defer as long as possible an appointment until I see you. However, what happens between today and the next appointment, I have no idea what's happening to you. And sometimes some of my colleagues, or obviously some of my colleagues, some contemporaries will say that it's best that I do not know as well. Because then the more I know, the more I feel that to do something, right? Because the action will and if you have been a healthcare user yourself, you know that it's tremendously complex. I wouldn't even use the word complicated. Healthcare is tremendously complex. Even for myself, 25 years in healthcare, I need to go to the hospital to do something I get lost. I have difficulty following the directions, getting the forms, and doing all sorts of stuff to get my appointments done. Okay. The last but not least is the healthcare is intensively human oriented, which is one of the primary drivers of cost, especially in Singapore. But that's because we always, at ND and some of the other speakers talked about doctor-patient relationship, therapeutic alliance, which is, and has a notion among even my contemporaries that has to be very human touch, high human touch centric. So all these actually gives rise to a lot of challenges that we face in healthcare today. So then the question I had together in my group is, can we do something about it? Does it need to necessarily be in this manner? Can we use our patients a little bit better such that we engage them? Can they be their own healthcare deliverers and healthcare providers? Next slide. So we thought about this particular project. And really, the name of how hopes came about is tongue in cheek. It literally means what it's trying to do. Health outcomes via positive engagement and self-empowerment. Right? So 3 key areas: improving the outcomes of patients with mental disorders. We leverage on passive and active digital data as smartphones. So Project Hopes is not a digital mental health project, and only just about the app. We're just leveraging on the data that we collect digitally so that we can empower the users with the knowledge of their own health, and also the healthcare, the clinician with knowledge about what is happening,
and we can then provide more proactive healthcare services. Of course, also personalized digital intervention. I'll come to that next slide. So we first started in 2019. I think it took a couple of very senior fellows to actually brainstorm and think about the potential of digital phenotyping in mental health. So I still remember how it happened, when it happened. I just got dragged to the particular meeting and to think about making it work. And then in 2018, 2019, when we started brainstorming and thinking about this was really in its infancy in mental health. So a lot of the clinicians and actually also the engineers, we don't really know whether this will work, how feasible it's going to be, actually what kind of digital data can we collect. So we started off with first an observational study. Let's try and understand the scale of digital data we can collect, the type of clinical data that can be predicted based on digital data. And we decided to zoom in on patients with disease who were just discharged from the hospital. And this is basically the phase A project. So the picture on the top right actually shows you the platform that was created together with MOHT. There's an entirely passive app called the Hopes app that we onboard all patients on. The patient don't need to engage with the engine runs on the backend, collecting all the digital data. And it's also every patient will also have a Fitbit charge device that they have. And on the charge device, we collect all sorts of healthcare data that any charge device can collect, which is your heart rate, variability, your sleep index, as well as physical activity. And on the phone, we basically collect any sensors that we have, from pets, the sociability, the GPS locations. And these two different data sources gets integrated on the Hopes engine for learning. And each patient that gets onboarded, we follow them out for 6 months duration. At 6 weekly interval, we come for regular intensive clinical and cognitive assessments across the 6 months. The main outcome we're looking for is really relapse, any form of relapse, unanticipated healthcare utilization. So we link that up with electronic medical reports over a 6 months period. So we enrolled 100 patients who were discharged from the hospital from between 2019 to 2023. Next slide. So the first thing we did was very quick, and then we all researchers are like that. So we just want to know what's the data telling us. So this is data coming from the first week of digital collection. So any patient that gets onboarded, we collect the data for the first week. We took all this digital data. We look at the first clinical assessments that we have. We look at actually, is it even making sense? Are there even signals that we have? So in the top panel, basically these are the list of clinical assessments, current structured clinical assessments in psychiatry that we use in all research and all clinical trials. We look at the symptoms. We look at specifically negative symptoms. This is an area I'm interested in because I do have a hypothesis that negative symptoms in patients with psychosis, which are things that they reduce speech, reduce volition, reduce movement, reduce sociality. These are certain behaviors that we can capture digitally. We also look at depressive symptoms. We look at the functional status, and we look at the cognitive function across the 6 months period. And the next two panels basically breaks down each individual symptom scale into various kind of symptom domains. Of course, then in the traditional statistical way, we will do 100 multiple, correlational metrics, and then you basically get killed by one for itself. So what we did was, we're not going to do it that way. We want to look at patterns and because we are looking at an eventual solution, which is to apply something like that in the clinical practice. I'm not looking at a single correlation, a single effect size. I'm looking at a triangulation based on pattern that's emerging. And the patterns actually that emerged were all, number one, they were consistent and they were congruent. Can I have the next slide, please? Next slide. And they were, sorry, before. All right. So the patterns that were emerging were really actually quite interesting. So we found that the digital signals could be, for example, from irregular sleep patterns, their step counts, their GPS mobility, which tells us the location variance across time. We look at the tapping speed when they tap on the phone metrics. We also look at missing digital data. For researchers, missing data is horrible, right? So I'm going to impute and think of ways of how to kill off the particular participant, right? But in this case, missing digital data was a clinical signal. It's a signal of digital disengagement, which is, for clinicians to understand, there's also a signal for clinical disengagement. We also were looking at things like phone usage, screen time, okay? And the correlations that we found were again clinically quite intuitive. So the individuals who have increased negative symptoms, they're asocial, avolitional. We see that in terms of the GPS signal patterns, they were not moving so much. We also see that in terms of their step count. We also see some patterns across their sleep. The other interesting finding that came out was the completeness of data that we could collect. So when I started this study, a lot of the clinicians, like my RID members were saying, this is not possible, right? You are enrolling patients who recently had a psychotic episode, they are paranoid, they're probably hallucinating, and you think that you can additional remote monitoring on them. On top of that, how are you going to get them to comply to wearing the wearable over a 6 months period? So what we found in the first week was in terms of Fitbit data compliance with 91%. In terms of smartphone compliance, 82%. Now the Fitbit compliance at 91%, this is not just wearing for 1 day, this is wearing for 22 hours over the day because we wanted sleep data. Now what we did build into this the project was we incentivize patients for complete data capture. So if they give us things like more than 22 hours of the day across the whole week of the monitoring period, we give them an additional financial incentive. And this incentivizes them to put it on the little bit more. And also throughout the course of the research, when we see the data compliance dipping, then we do a friendly phone call and check in with them and say, if you want to sync your phone, when you turn on your Fitbit, is there any on your Fitbit or actually your Cohorts application. Next slide. So of course, then this is now the next holy grail, predicting relapse. The goal of treatment in schizophrenia after inducing a response or remission is to prevent the next episode. Multiple clinical observational studies have shown the more episodes, the more relapse, the more treatment resistant you become, the poorer the outcome is going to be. So all focus in terms of intervention is always on preventing the relapse. So in this study, we tried to predict whether we can see digital markers can predict relapse. And the way we define relapse was basically an increase in the clinical global impression or CGI scale that's assessed by clinicians in terms of deterioration. We also look at any readmissions that's due to a psychotic episode. Right? This is a key classifier because in most current, actually right now there's a review paper going on taking a look at how do we define relapse in psychosis. Some people use readmissions, and actually if you look at hospitalization, it's a very complex outcome. It can be because of relapse, but also because of a lot of social indicators. So in this study, we actually separated the different types of readmission outcomes. We also took a look at emergency room visits that aren't scheduled, but typically these are important outcome indicators. So we looked at whether the digital data over the 6 months at any point in time could they anticipate or predict such outcome variables. You can take a look at readmissions being highly anticipatable using the digital data. And what's more interesting is that even across all, when we look at control events, we have an accuracy of about 90% in terms of predicting any of these events. On the next chart, we took a look at the sensitivity and specificity of predicting any of these 4 stated clinical events. It was as high as 91.5%. Now, the harmonic mean over here, that's because Robert talked about this earlier. Traditionally, we look at sensitivity, specificity, accuracy, as if you know, so gold standard metrics. Now, in this case, because we're looking at a proactive clinical algorithm to predict, we wanted to err on the side of clinical or sensitivity. So we decided to weight the model a little bit heavily on sensitivity so we can identify events to improve the accuracy of the model. Next. So the other kind of analysis we did in this data set was trying to actually address some of the concerns from people who are doing something like that. So number one was actually taking a look at the assessment window. So how long a digital window, monitoring window do we need to predict the relapse outcome? Is it 1 day, 3 days, 5 days, or do I need 6 months of data? So in this particular analysis, we looked at it as a weekly interval. Now, why 1 week? Because we think that Monday to Fridays is very different from Saturdays and Sundays. I think all of us can understand that. So we run it as a 7-day window. 7, 14, 21, 28, as well as 35. And you can see across the different models is certain plateauing at about 21 days. So 21-day kind of assessment window appears to give us some plateau of peak prediction performance and result. The next thing we did was to compare different feature sets. Fitbit plus smartphone, let's call it a full feature set. A lot of digital data that we create. Before we actually start, along the way when we started this study, we did ask some young people, which kind of digital data do you not like? You find it too intrusive. So GPS was something that people felt too intrusive. Second, looking at my messages, social messaging, that was also quite intrusive. So in this, what we did was we did a reduced feature set, where with the complete data set that we have, let's exclude things like sociability, which is basically indexes from number of phone calls you make, how many messages you have, how many unique people that you communicate with, as well as the GPS, so basically location. On top of that, we remove sleep, because we know that sometimes in the natural setting, none of us are going to wear a Fitbit to sleep. So this is called the reduced feature set. The other 2 feature set was a phone only or wearable only feature set. Now that's because some of my contemporaries who doing this research overseas felt that asking a person to wear a wearable for long periods of time is not feasible. So they decided to focus the entire research efforts on only just the phone itself. So in this data set now, we have the data to actually take a look at comparisons. So if you look at this, the green The blue box is basically the full feature set. The orange is the reduced feature set, removing invasive indicators that our use told us. Green is the phone, red is the risk only. And by looking at the metrics, you can see that the blue and the green boxes tend to stay at the top in terms of the prediction analytics, telling me that the full feature set and the phone only feature set appears to be fairly comparable in terms of prediction metrics for relapse or clinical adverse events. Whereas if I look at the reduced feature set, the risk only tends to be slightly inferior. Now, even though it's slightly inferior, having a predictability of 70 to 75% is really not that bad. It's really quite good. But then going forward, that what this also tells us is that we can probably do away with without maybe just a phone only. But we need to be able to find a way to gather the depth and the comprehensiveness of the digital data set that we have today in this HOPE data. Next step. Now, on top of this traditional kind of research, what we did was we went to survey some of these patients who were on this study over the last 6 months. One-to-one, we speak to them and find out from them what they actually want from a digital setup, now that they experienced it. And this actually is not their verbatim replies. So they kind of, in general, most of them like this, all right? And they thought that they give a certain degree of connection. Now, even though there's no proactive clinician call to them, but having that set up and the feeling that they're actually being monitored actually gave them a sense of connectivity to the clinical care team. And that is actually quite important. So they also gave a lot of kind of ideas. Across all 100 patients that we have after they finish the study, we asked them the degree of acceptability this kind of monitoring system have. On a scale of 1 to 7, 7 being highly acceptable, it was a 6.1 on average, indicating actually quite highly acceptable to most of our patients. And this additional thematic analysis that emerged was basically the patient's one is set up that helps them in terms of goal setting, very similar to I think the early morning parts. They want reliable resources on the setup so that they can refer to. They want this setup to be recovery oriented. They don't want it to be illness. Don't call it a relapse app. Don't call it a psychosis app. They want it branded as a recovery and wellness kind of setup. They want us to give them feedback, their own dashboard, but they want us not to overreact to every single anomaly that we do, which is I thought quite mature of them. Some of them asked for caregiver application, but when they raised that, they also had worry. What should I tell my care? What do I want to let my caregiver know about me? Right? So that's to be determined. Next slide. And I mean, I said that we started this study in November 2019, right? So lo and behold, 2020 COVID struck. Of course, we held back a lot of our recruitment, but we took the opportunity to get an MOHT to trial something like MyLine.sg, and this was the first time we had some early kind of learning of how we can deploy something that works. Next slide. So in phase B, together with the clinicians in IH, we sort of thought through the entire process, and as well as the focus group feedback, we think that we can actually combine the different systems into a trans-diagnostic digital mental health setup, leveraging on digital phenotyping as a tool, enhance self-management and improve the connectivity. Next slide. And really also because a lot of the interventions, for example, your moods, your emotions, your sleep, as well as improving your physical activity, they are not only unique to patients with schizophrenia, patients with depression, patients with anxiety, or even bipolar disorder. They're actually trans-diagnostic in terms of interventions. So this is actually version 2 or version 3. Actually, they are quite there are various versions now, but they look probably the same. So you see how the app actually looks like. We have an inspirational quotes, which a lot of patients actually do like. We also have a journaling kind of setup. That's because we thought some patients actually want to write down their thoughts or use that as a way for them to collate information and help them in the next concept. But we told them that whatever you journal is only on the phone, it doesn't go to the cloud. Complete privacy. Okay. But of course, if the phone hangs out, let us say your journal is gone. For every single patient, we have at the bottom, I think you can't see on the left-hand panel. Basically, we have a relapse signature. So each individual, when they on board, my case manager work really well, and list down their early relapse signs. The next button will be their coping strategies that they work with the case manager that has worked for them. So this is the personalization that's being done. Now this will come in useful later on. I'll show you in the model. Next slide. So in this particular setup and model, this is what we did. We using the digital signals, the data engineers basically worked out a way to detect intra-individual anomaly, and using the intra-individual anomaly and basically some way to look at how far I deviate before sending a signal, whether this is a green, a yellow, or a red kind of signal. And this goes into particular dashboard. So we monitor various things from the digital setup as well as EME. So we started the ecological momentary assessment to take a look at the self-reported mood states. We ask them to do at least twice a day, morning and evening, if we can, and we can trend their mood states. Every time they report a low mood or high or good mood, we ask them what is causing them to feel this way. Is it, your friends, your family, your illness, or is it because of some other reasons? And they can shoot this down. And over time, we can collate their mood as well as the factors associated with this mood, helps them to enhance their emotional awareness as well as the case managers. Now, we also have clinician-defined algorithm, and this is really to address the clinicians who are skeptical about whether this will work. So then what we did was, we asked the clinicians, what do we normally do? We asked about mood, we have medical consult, we asked them about, are you sleeping well? And based on this, we created certain algorithms to help us to categorize them, right? So if you don't sleep so well, maybe 3 to 4 days over the last 1 week, then maybe this is like a yellow or red kind of signal. Or in the last 1 week, maybe you get 3 to 4 days of moods that are reported as low, maybe this is like a red or yellow or red on the dashboard. And this particular signals gets prioritized based on our machine learning models that we got. Next slide. So then this is how the dashboard looks like. So we have a connected care specialist that does remote monitoring on this end. She will, every morning when he or she comes to work, this dashboard, will log in, take a look at this dashboard. We should then up triage any individual that's red or yellow on any of the signals. You can click on that row and you expand to the intra-individual profile. They take a look at the sleep, the mood score, any of the relapse symptoms that they endorse, and whether they think that they're really okay, any distress related to that symptom. And we can see the longitudinal trend of this individual across time. Now, if the connected care specialist think that this is a positive at risk individual, something that's happened, what this person can do is that I can either drop a text message to the patient to check in on him to see how you are, or I can actually escalate this person to the clinical care team, which is the case manager or whoever is the onboarded clinician. Right? And the case manager will then start getting regular daily updates of this person from the digital signals, and they can also take a look at the phenotype of this individual. Next slide. So with that setup that we have created based on HOPES A have done, as well as the personalized setup, we designed a series of phases to try this out. So we just recently completed phase 1, which is really looking at usability and feasibility among 40 patients. I have about 2 to 3 patients on this. My boss has about 3 patients on this particular setup. Next slide. So I'll show you some early kind of findings from there. So we have about, actually right now we have about 40. This was actually done on January. Various kind of diagnoses, psychosis, as well as mood diagnoses. Next slide. So we completed 19 patient interviews. We actually spoke to every single one of them. This was part of the process. So we asked them to assess the platform using this skill called the system usability skill. So they rated us as a research, which is above average. Almost 90% of the patients that were on the system, reported that there was comfort in being monitored remotely. This is contrary to common belief that they feel paranoid. Now, 79% of the users found that the features of the HOPES application useful. So these are the resources, the journaling, the dashboard. 74% of them felt that we have seen positive changes in themselves since they came onto them. Unfortunately, we didn't go further to quantify what these changes. And about 3/4 of them shared that they recommend the application to some of their peers to use. Right? Next. So we look at the technical use matrix as well. So about 3/4 of the users read a feedback for more than 12 hours a day. This is in a natural, unincentivized setting. The where to sit ratio is about 58%, but what we begin to find out was actually contrary to HOPES A, which is collect all the data and analyze. And dynamic setting is a bit asynchronous because it depends on when they see the feedback. So my lack of sleep the last 3 days, I could probably only find out 1 week later when they see the feedback. We took a look at whether how many of them actually took a look at the resources. We also asked them about EME, so about 40% of the users share their notes, probably more regularly. Next. So remember earlier I told you about the clinician metrics, their mood charting, their sleep charting, what is a red, what is a yellow. So we tried to back test the logic onto HOPES A, depending on whether this person has got sleep, has got some difficulties in sleep. If you don't sleep 3 days or 4 days of the week, what did that mean in the HOPES setup? So in the observational study, where we applied the RYG algorithm onto the data set, we found that you only had a 12% sensitivity to pick up any clinical adverse events. But the machine learning algorithm gave us an 81%. I feel a little bit sad as a clinician. That means that the machine actually does better than me in terms of predicting the clinical adverse outcomes, but this is what the data shows, right? Next slide. So this is a real life. This is actually somebody who contacted our folks on her own to tell us that she has benefited from the system and she was actually quite happy. And we asked her specifically what was it on the system that she found especially helpful. So she liked that she could note down her mood states. She had better awareness of her emotional states. She knows her relapse signs. She knows who the contact because of every patient that on board. We not only provide the IMH helpline as the 24/7. We also ask them to put in their contacts that they think they want to call with their need. So it's there, it can be a case manager, it can be a mother, it can be a friend. We put it there. So when any risk emerges, we can ask you, do you want to call someone? And who do you want to call? And it's a quick call, fast call. You don't have to dig through your contacts to find who to call. Next slide. And that's not it. So like I said, COPS is a huge project. Now in this particular project organization that we put up last year, it's not just engineers and myself. So we included engineers who look after the engineering part in terms of system. We have clinical implementation, evaluation setup. But most important, I think that was key to one of the success of this is actually really having a clinician review work group and a co-creation work group, co-consulting and co-creation work group with peers or persons with lived experiences. So these two work groups work hand in hand to help us review the resources, the use case, the ROIG algorithm, the dashboard, how it will look like, what should be there. And the patient, rather the persons with lived experience tell us what is needed, how to nuance the messaging, what kind of setup is required, how do we bring across certain messages that is not excessively alarmist. Next. So really you are trying to shift healthcare from something that's reactive that I do not know and don't want to know to something that's a little bit more proactive, which is I engage now the service user in the entire healthcare system by providing them with information. And I'm turning that reactivity into a proactive one so that if something happens and I pick up the signal, the healthcare provider will reach out to you first, even before perhaps you know about it. Next. So what does hope to bring in terms of change? So for our patients, actually owning their recovery, we give you your healthcare data and your mental health status. We give you access to curated psychoeducation materials that peers work together with clinicians to develop for you, and that's an ongoing expansion. Provide you needs-based intervention because you marry the MindLine Wiser kind of chatbot into the system such that they can access your chatbot 24/7. And for healthcare providers now, I have objective data. No longer now do I need to ask a patient after 3 months how was your sleep. My patient will think about, are you asking me yesterday's sleep, last month's sleep, or 3 months ago? Because now I can actually see in time. And real life example, because I do have a patient on this system, and when I always reported some difficulties, and we took a look, I took a look personally at the sleep profile, and you could see that the sleep and the mood dips usually on working days, and on weekends it gets better. She didn't realize it, but when the pattern began emerging weeks on, it was something that we could then bring about to talk within the clinic. A clean dash to prioritize cases as well as to help us understand better patients' illness recovery in real world. Next. So Hollywood was a bit earlier than me, but this basically gives me the kind of vision of what it's going to be. What we haven't reached yet for folks is something that really has got tactile sensation. We believe in the magic of a heart. So that might be the future to go. Maybe when this is beyond VR or AR, this is something that's really to give a kind of tactile somatic sensation. Thank you. Any questions for Dr. Jimmy?
It's actually quite interesting that the phone data itself, it seems to be more accurate than wearables. Yeah. What do you think is the reason for that? And what's the implication for us moving forward for digital phenotyping?
Okay, so I'll give a couple of ideas. That's assuming that you've got all the data from the phone and we're using iOS, it's a huge problem, right? And for Android systems, so for this, when we took a look at the different engineered features that were most predictive, actually was patient. So, and overseas, some people have just developed digital platforms for psychosis after psychosis, solely just based on GPS alone. Basically, what our data seems to confirm. Because when we look at the GPS, I'm not looking at basically where you are. And we told our patients, basically when we onboard the patient and we take consent, we go to great lengths to show the patient the kind of data that we're collecting. We don't collect the exact location, we just collect movement metrics. We tell them exactly what we collect in terms of speech and data so they have a better awareness before making the informed consent, right? Now, the location basically tells us it's a feature of your functioning. Because if you're someone who's working, you'll be leaving the house. But if you're not working, you just home bound, very asocial. You see that location doesn't move very much. That said, we also had a patient a week before he relapsed, the movement suddenly went to 30,000 steps in a day. So basically what you're looking at is not just the location, you're looking at the change in the person's behavior.
Any other questions? No. Okay, can we thank Dr. Jimmy again for his talk? Thank you. So up next, we have Dr. Creighton Heaukulani. Creighton is a senior data scientist at MOHT, and his work focuses in the interface of digital health and machine learning. And as the final speaker, it is my distinct pleasure to invite Creighton to explain to us how can AI accelerate discovery. Thank you.
Thank you, Lian. So I've got my own, for my own slides, because I have a lot of transitions. So I know I'm your last talk, and thank you for sticking around. I would try and read the energy in the room, because I'm actually going to try and describe a particular type of AI method called transfer learning. Who has heard of it before and knows what it is? Okay, it's a good measure of the engineers and data scientists in the room. Okay, if you're not an engineer or a data scientist, my goal is to try and tell you why it's interesting and important, and hopefully it's useful. But actually tying into the themes of the workshop, I'm not really sure if it's been very clear to you throughout the day, but actually we had a very concrete message that we wanted to get across, which was that AI-based digital phenotyping and interventions is already accelerating the research process. And all the talks that were happening today were demonstrating how that's actually been done. So I'm going to try and drive that point home one more time today. So thinking about research kind of in healthcare, it actually drives everything we do in healthcare. I've only been in healthcare for 5 years before this. From my view, actually, I think healthcare is one of the most data-driven, research-driven, evidence-driven fields that I've seen. Everything is evidence-based, kind of like they ask you for evidence for everything, even things that I think are a bit obvious. They say, oh, what evidence do you have? Show me the study, show me the RCT. But it's time-consuming and expensive, right? And that's sort of kind of the bottleneck in some sense. And as a case study, HOPES, which you just heard about, I swear I spend most of my day working with Dr. Jimmy and Robert on HOPES, was in schizophrenia. So it was 100 patients in schizophrenia. We took 3 years to run the study, and we were slowed down by COVID, but in reality, we weren't slowed down that much by COVID. It just takes a long time to recruit these things and run these things. Think about the budget, however much it costs. Now we want to expand to depression. So we now, actually the clinical service already has depression patients on it. And we want to adopt all the technologies, the algorithms that we've developed for depression patients. What do? Do you go and run another study? Go recruit another cohort of 100 to 300 patients, spend $1 million or $4 million if you're running an RCT. So I want to talk about in this talk a few AI methods that can help you fast forward that process. So this is kind of our strategy on a slide. We started down kind of at the bottom, which is, don't worry if you can't read it at the back or anything, these are just my references. But at the bottom is sort of psychosis, which is sort of the narrow point. HOPE started there and it expanded out to the orange circle. Okay, my point is not working. Put it out to the orange circle because now we're including depression. Again, do I run a depression trial? We would love to hit other things like bipolar disorder. Do I run a bipolar trial? Do I have to run all these research studies every time I do it? We actually started at the other end of the spectrum too. With Dr. Jimmy and IMH, we work on MindLine, which Prof. Daniel spoke of. MindLine currently does not use digital phenotyping in it, but we want to. We want to move into the wellness space, not clinical, not diagnosed patients. Prof. Andy, actually, we've been talking and we've been trying to work on something together where we do use digital phenotyping in a well setting, in students in particular. And we want to work our way into the middle. Healthier SG is here, right? We already have been called upon Healthier SG, working with primary care. We want to work with schools and students, community health providers. So again, I want to expand our digital phenotyping strategy to the whole mental health and wellness spectrum. I want to go beyond mental health. We want to go to physical conditions, you name it. But yeah, again, do I have to go through that research cycle every time? So here is a picture of what that research cycle could look like. Traditionally, this is what your traditional cycle looks like. You hypothesize these associative and causal factors. You have some theory of why you think it might look that way. You then go and convince a funder and an IRB board that you want to run a study. You go recruit that cohort and collect their data. You then find the features that you hypothesize. You find whether you validate whether or not they are predictive of what you care about. You optimize it. You might have to go and run another study. Let's say you actually have better features, some better GPS measure, some better heart rate measure. You have to go run another study. You have this loop that you have to kind of go through until you get optimal features. One fine day, you're ready and you run your RCT. You run your RCT. Hopefully, if that goes well, then you deploy your intervention, then you have some impact and you save the world, right? Now, what happens when you have an adjacent population? So again, for us, it's from schizophrenia to depression. You have to repeat the whole cycle again, right? So you kind of start at the beginning of this chain. Here is actually what I would propose is the accelerated research process driven by AI in digital phenotyping. It actually starts not necessarily by sort of like hypothesizing what the factors are already. It actually starts with collecting exploratory data sets, exploratory cohort data sets. So they have to be somewhat open-ended in some sense, collect a lot of data. Then you actually let AI discover the features you care about, discover the features that are most associated with your condition or with an event, like for us, psychosis relapse. It actually already can engineer itself, right? That's the whole point of much of machine learning is sort of engineering your own features, automatically engineering features. You still need to run your study eventually, right? You still need to recruit those depression patients, you need to validate, run an RCT, so you can't get away from that. But what I'm proposing is that, or what we are proposing, sorry, is that this strategy can sort of maybe eliminate some of these cycles through the research process. Might not need an RCT. We actually don't think well, I shouldn't say it, never mind. Yeah. Okay, so this strategy sort of depends on these large and exploratory cohorts. So it is sort of like a big data hog sort of thing. You know, HOPES actually, we believe, is the largest data set of schizophrenia phenotypes, as far as we are aware. So it's a very, very big data set. Gusto, Prof Meaney was talking about earlier, again, big, one of the biggest data sets of its kind in the world, the biggest. If you can get access to things like Cosmos, so you can get things, these massive longitudinal, very broad data sets. And if you're listening to Robert at the beginning of the day, you can think of these in and of themselves as sort of foundation models, right? When people use that word, if I may use it loosely. So they're data hogs. And you can sort of put it on this sort of life course that we pitched. Robert also showed this slide, but I'm showing that a lot of these foundation model-like data sets, let's say your medical literature and even the LLMs that are already trained on healthcare, MedPalm, I don't know, you name it, Cosmos. We have our local things like all the health records. For those of you who kind of like want to go and access trust, actually somebody in my breakout session group was complaining that trust is very, very expensive. So I had never heard that complaint before, but also, we want to propose these things like these cohort data sets. So if you start with Gusto, right, Prof Meaney is not here, but you start with Gusto, we would love for you to like then stitch on that Gusto to like a use cohort trial. So Prof Andy, if maybe we can, what we want to do with students, maybe we stitch it up to Gusto and we sort of have this lifelong massive study. NUS has this study called NUS 1000. They have 1,000 students they've been collecting digital phenotyping measures from. And you can continue on. Even we have our disease condition-specific ones like HOPES, PTEC, and AMI HOPE, which was mentioned earlier, hypertension, heart attack, kind of thing. But the point I want to make is that no matter how much of these you run, you're never going to collect everything you're interested in, and you always have the next problem to solve, right? Our jobs are not thankless tasks, but are endless tasks that we must continue improving different healthcare problems in healthcare. So one thing like we can propose is to speed up the process by doing something called transfer learning. So the question I pose to you is, what can you do with, or what can you say about new conditions for which you have very little or no data? So instead of a big data problem, now we're in a small data problem, right? Instead of like a small no data. Turns out, actually, people have been doing this for a long time in computer science and engineering. You can do very intelligent things if you have big data in something else kind of close by. So that's the kind of purpose behind transfer learning. So again, my running example is going to be schizophrenia and HOPES, and we want to serve our depression patients better. So this is from Wikipedia. It's definition of transfer learning for those who can't read it at the back. Transfer learning is a technique in machine learning in which knowledge learned from a task is reused to boost performance on a related task. So here is a classic picture that everyone, if you go talk to anyone in machine learning, they're going to show you this picture. So the idea being, obviously nowadays everything is a deep learning thing. So you start at the top with, let's say, an ImageNet data set. These are all these images, cats on the internet. You have some deep learning model that's kind of sitting here as a black box. You have some layers that are touching the output data. And here you want to predict some class, like image of a cat, image of a dog, image of a spoon is the example here. Transfer learning involves actually setting up a very, very, very similar looking architecture. In fact, you copy, literally what you do is you copy the data that's inside this architecture over to a new one. You then feed in data from the front that's very different, but like such as medical images, not kind of images of cats. And then you allow sort of the layers that are close to the data to kind of get retrained. And then you predict things like whether or not you have a benign or a malignant melanoma. Oops. So that's the idea behind transfer learning. It is similar if you think about fine tuning, but it actually is different. The mechanisms involved are different. Things you're trying to do is fine tuning. Anyways. So the whole point is that reusing or transferring this information from previously learned tasks will significantly speed up your learning efficiency, save you time, save you money. Maybe. Okay, I'm going to go a little bit deeper and hope that maybe this is fun for you to learn about. But one approach I really like and that we've already started doing in HOPES is something called state space modeling. Don't worry, I will be gentle with this. So this one diagram is the main thing I want you to maybe take home. And actually, it's something that's very, very well studied, and you'll probably like to see it. The blue are your data, the things you actually observe. And in state space models, you assume that there are these latent variables, these latent parameters that need to be estimated there at the given states, and they evolve over time. And the blue data is what you actually observe. So that first diagram, where you see the arrows pointing up, that's actually largely the class of models that recurrent neural networks fall under. If you don't know what that is, LLMs. All of your LLMs are fundamentally of this class. I don't care what it says. That's the base, what's sitting at the base. The other one, I put it up on the screen because it's very popular in healthcare. These are hidden Markov models. They're one of the most popular things that have long been used in healthcare. And why are they popular? Because in these types of models, the inferential task of learning something interpretable about the health state is often more important to you than making a prediction. So actually in these tasks, oftentimes you don't care about what you're actually trying to predict. You actually care about what you can say about the patient's health state or something evolving over time. Sometimes you care about both. So a great example is in HOPES, which Dr. Jimmy just presented. In HOPES, actually, the real model that describes our scenario is this health state that's evolving over time, something you never really observe if you think about it. And actually the clinical scales that we're measuring, these are surveys measuring symptoms and functioning, levels of depression, levels of anxiety. That's actually what you're measuring, right? It's some sort of emission, data that's emitted off of your health state. And the bio and behavioral markers, they're actually also just things that are emitted off of the health state, right? They're just how much you go outside, things like that. So actually the directions of the arrows are important. Those are causal arrows describing to you what depends on what. That's kind of what I wrote there. And so one of the questions, yeah, I'll go for it. So if you think, well, what does impact the health state? Well, maybe there's some things that we can never really truly understand, something in physiology, I don't know. In mental health, something physiologically happening in the brain. But a lot of it is environment. A lot of it is happening in the environment. And also your interventions, any interventions you take. So this setup actually that you're seeing is actually the backbone of reinforcement learning. If you hear about reinforcement learning, control theory, people in robotics have been studying this for many, many decades. And actually people in healthcare, you might not know it, but people in healthcare are doing this too. So the question I want to ask you, maybe in schizophrenia, in HOPES, do you care about predicting your clinical scales? Or do you care about inferring the health state of the patient that's evolving over time? It's actually not an easy question to answer. You can say both. You're allowed to say that you care about both, in which case there are some models that are pretty good at both. Deep learning community people are actually pretty good nowadays at both. So if this is the general setup, one thing I want to do in HOPES that we are trying to do, can you transfer knowledge from your schizophrenia, the scales we have measured for schizophrenia? Can we transfer that knowledge to, let's say, scales for depression? I don't have. We have not run a study with depression. So in some sense, I'm actually trying to treat the state model as sort of a foundation model, if you will. Okay, pretty much only 2 slides left, bear with me. This is one cartoon of how it's done. You first train your state space model without the clinical scales. So this has no idea about the scales. So it's actually unsupervised, if you know what the term unsupervised learning is. This is an unsupervised learning. You then train a model with the scales. So this is a model with the schizophrenia scales on them. And then you ask your question, what changed? Between the 2 models you learned, what's different? If you can infer what this health state means, and you can see how it's changed once you put in the schizophrenia specific information, then in some sense you've learned something about how schizophrenia scales relate to underlying health state. Then you find your knowledge of how schizophrenia and depression are related or different from the literature, let's say. Or you take your knowledge of how you know certain types of patient health states are particular in depression. And if you can encode that knowledge that you take into your statistical model, then you can come up with this new model, your transfer learning model. This transfer learning model does not have depression scales. So that piece in the box, I don't have that data. That is a prediction. That is a prediction that depends on the assumptions of your model, assumptions of your transfer learning. So this is something that we're trying to do. I swear that's the last slide I have on it. It's something that's pretty well studied in machine learning and in healthcare. There's a lot of people around the world that I really like to work on this. We're actually starting to work, Prof Vanishar at Cambridge, we're trying to organize a workshop with her. Prof Doshi at Harvard, actually, she will probably start working with us on HOPES very, very soon, working on things like this. And actually, another one is Prof Alexander Thierry, who's at NUS. He's the world leader in these state-space models. He's actually already done some work for us. So this is results actually on HOPES, on our HOPES phase A data set. And actually, you don't have to care about what this is, but we posed a latent dimension size of 4 factors. So these are 4 underlying health state factors. Here's a simple example, whether or not a patient is on the medication or off the medication. That could be a good example of a state that evolves over time. So the idea being when a patient changes state to not being on their medication, how does it change your data that you observe? That, what you see here plotted is how it changes. These are weightings in the emission matrix, in what people call the emission matrix from the state. I'm not going to go too much into it, but some things you can poke around at are, one factor has high sleep efficiency and high heart rate. Another one has our height rate, moderately high sleep, low sociability, low going out. Perhaps you can try and infer these things and how they evolve over time. Okay, I do think that is my last slide. This is my last slide. So yeah, what we are trying to do is just basically, as I say, kind of fast forward the research cycle, transfer over from schizophrenia to depression, and hopefully save us a great deal of time and money. I'm sorry, this is my last slide because I've been talking about finding markers, but I didn't talk about interventions. Well, actually, just in the same way that you can transfer for those markers, you can also consider transferring for interventions. So in like the simplest examples, think about your LLMs for your mental health assistance, which we are doing. Prof Daniel described that project earlier. Can you transfer what you've learned to, let's say, coming up with LLMs for clinical decision support? You can. People do this all over the world, actually, and this is sort of the architecture they look at. Same picture from before, but just different. Okay. With that, I think that is officially all I have. This is the summary of the main points, but I'm not going to go over.
Thank you. Any questions for Creighton?
Thanks for sharing. So I think we have the talk we have on the table.
Yeah.
Maybe one question about the transfer learning that you are finding or trying to find the hidden features to help you understanding a new space, new condition. How about like a closing the loop that using this as a guidance to design your next trial?
Yeah. So yeah, definitely. That's what we want to do. So in depression, for example, Ono was working on this too in the back. We want to talk with him. So yeah, we are trying to learn if we can learn some underlying health states, if we can interpret it based on the data, like the digital phenotyping data, and then we can sort of identify it. In state-space models, people call this process identification. So if we can identify that state, let's say a good example is the on medication, off medication state. If you think pretty reliably you can identify it, then you just find in the literature what people say about that state and depression. You posit a new model for it, and then we have to run a study at some point. You got to validate it, right? But the idea being we don't have to run another HOPES phase A, possibly. So that's kind of how we hope to save time and money. But I don't know if that makes sense.
Any other questions for Creighton? Yeah.
This is Aditya from Sciences A-Star. Well, it's not really general because I think it's very interesting on this model and all the factors interacting. And it's more mainly below this. We know there is also with schizophrenia, this metabolism. So, and this is something also we are looking at daytime last also.
how microenvironments affect depression, also healthy lifestyle, the kind of food you're eating also is part of this aspect of the mental health. So I want to ask if also this is related or this is actually considering this model.
Yeah, so actually, if you think about the state, the underlying state, that's actually, in some sense, one of the main motivations for why you develop these models. Yeah, there is something that fundamentally you don't really measure. I mean, if you measure it, you actually don't really need this if you think about it. But if you can't really measure something that's actually quite hard to measure, then yeah, the interpretation being that that is some physiological process. I don't know, the amount of a hormone that's currently circulating in your body. Sure, that is the underlying state possibly. There are many interpretations of the state, and in fact, one of the main hallmarks of these models that it's very hard to interpret what that state is, but that's kind of why we sort of designed sort of what they're inspired. It's kind of the origin of these things. These things originated in robotics and sort of like satellites and stuff in the world. They started off with just sort of the position of a robot and some characteristics of its movement, like momentum and velocity and like acceleration. But now as data has gotten much bigger, right, we have 4,200 digital phenotyping features. The interpretation of the state has become a little bit more obtuse. So we hope we can identify those things, but
Thanks for the talk. Just curious, do you consider, for example, clustering a priori certain parameters before training the model? So like say you have in the literature, you know that there's good sleepers and bad sleepers. Can you, before you train the model, can you break them up and then train that model? Is that something that you do, or is it going to kind of contaminate the data?
so you certainly can, but actually nowadays you generally don't. Generally we let it be discovered because it's actually quite easy to discover. If those clusters exist, it's quite easy to discover them. And I guess it's always better to have the data tell you what clusters exist rather than you kind of impose it upon them. But with that said, if you have some assumptions with how your patients should behave or the different phenotypes that do exist, then yeah, you can certainly try it out, and it could possibly tell you very, very interesting things. So you could sidestep the problem that I'm describing, that in state space models, sometimes you can never really identify the state. So sometimes it's very, very interpretable, especially with the linear models. But when you get to like deep learning models, they're like this heinous looking thing. Sometimes you can never truly interpret what they do. Most machine learning conferences, people working on this stuff, they actually are just trying to come up with some basic resemblance of an interpretation of a deep learning recurrent neural network architecture. If you really were confident about your clusterings and you impose it from the get-go, you wouldn't have it. Sorry. Actually, I should, because then I can talk.
Thanks. For your state space models, I mean, like, you can get the right-hand side base two ways, right? One from the knowledge of depression state of or knowledge of schizo and depression. So you can get two totally different models and the rightmost, and then turn out maybe like one is right, one is wrong, and actually your knowledge of schizo and depression is actually totally wrong.
Yeah. So that is a model, and like all models, it has assumptions, and those assumptions could be right or wrong. And how do you know which one was better? You do have methods. You do have methods of telling you which ones were better or not. You could run an experiment where you have those two models that pose its knowledge of depression, let's say, and then and then you actually collect the depression examples. That's the only way to really know kind of which one was better. I'm afraid to say. I don't know if that's true. I'd have to think about it more.
Okay, so any other questions?
Sorry, no, that's not true. There are ways to do it. I can talk to you about it. I just thought of it.
Okay, let's thank Creighton again for the illuminating talk. Thank you. Okay, for our final session, let's have the sharing from the breakout session. So how we do this, I mean, this is perhaps what the other workshops are doing, is that we would have the breakout leaders come up and give a brief summary for about 5 minutes or so on their findings on what they have discussed. So without any order, I would call upon Dr. Gibi, who is the breakout lead for SA1 to talk. Okay, I'll wait for you. Yeah, Robert, would you like to talk about SA2?
We had a very dynamic group in SA2, very diverse. We had people from all branches of clinical. We had data scientists, AI engineers. We had, I think, an international visitor, Prof Kelvin Soy, who flew in from Hong Kong for this meeting. Thanks, Kelvin. We covered a lot of ground. And the questions are not up, but the questions were, can we automatically actually engineer best features? And the answer is clearly yes. I mean, in the work that Dr. Jimmy and Co have done, they actually started, they have 900 features, and they end up with a subset, like a few scores, which they are suitable for machine learning. And they end up with the ones we serve, like there's like, roughly speaking, 5 things that make the most difference. So you can discover them, and you can use them for clinical care. So pretty clear example. And I think the same thing is more obviously true in other diseases that have clear markers. You already have them, like for hypertension, etc., but you don't have them for you look at post-discharge recovery. You do not know what the pathway and what the features, like, for example, how does the patient learn? How do they change behavior? How amenable are they? Which language? What time of the day? All the things that Praveen talked about. So what we discussed was an example which Winchi from SHS SingHealth Pharmacy said, look, the patients come up to the counter in pharmacy to pick up their medicine. We have like a few minutes, maybe a minute with each one. And that's our chance to intervene as a clinical pharmacist to advise them. There's all kinds of information. If we had more time, we could tell, are they taking their medication? Because, they should have renewed 3 months ago and they haven't. It means they haven't been taking it. There's all kinds of things, family history and history of disease and progression of disease. So much we could do. Pharmacists are in Singapore are highly educated clinicians who at least one clinical trial has shown they are as qualified as senior consultants to advise patients on how to get better in many cases. So the data is so vast and it's not obtainable in a packaged form in 1 minute to do that. And that's a huge opportunity. We don't even know what the features are, but we're going to find out. There's an AI project going on. And Epic was in that group. So two esteemed colleagues, Scott and Matt from Epic, and they said, yeah, we have that. We have the pharmacy system. We're installing it in Singapore. It's called the Willow subsystem of Epic. And yeah, it does a bit of that, and it could do more. And then we have a platform we could close the loop, and whatever gets discovered, we could put it on, and they're open to do that. So that's just, we don't just kind of engineer we can only engineer the feature. We can close the loop and deliver it to patients. And by the way, does that mean we're going beyond the research? We're about research today. No, it doesn't. You'll never find out if it works. If you can't close the loop, if all you can do is a little experiment, you'll never complete your research. This is human behavior that we're talking about. If you can't get it onto the main screen in Epic, try it out and do significantly, you'll never refine the features, you'll never learn them, and you'll never actually have success. So yes, we can. We're now positioned to do that. Morning Feng, talking about risk score for failure. He's got models. Same issue. Actually, we've got the models and we've got the ways of addressing them, but it's not at this time easy to get them into production, which is this last step of closing with the, and there's a number of reasons for that, part of which is data classification, approvals by institution. The same thing came up from IMH, that even Daniel alone, the CEO, may not be able to approve the use of certain data because there are MOH, ministry regulations. However, there are ways, and there are, we now opened up access through trust so people can get the raw, complete longitudinal data. And there are ways now, we've actually declassified a lot of data. A lot of data has been declassified to the point where we now can export it. This happened within the last couple of years. We can export it, we can close the loop and put it to clinical use. Next topic, sharing data, similar experience on sharing of images, but with a new classification and the ability to declassify things if they're properly anonymized. And the standard is we just have to meet the PDPA standard. What's the PDPA standard? PDPA standard is no reasonable chance of re-identification, not no chance of identification, no reasonable chance of re-identification. It's actually very good. It's a very sensible, logical standard and leaves the door open for top-level research. We can do it. Benchmarks, we asked about benchmarks and data sets. We have a lot. We have all this longitudinal data. We have trust. We have actually a lot of data in HPV on behavior. It's never really been brought together with the clinical data, but people are starting to do that now. And one day we will love to have Cosmos from Epic, but we haven't crossed that bridge yet. And another question came up, which is, okay, this is all good, and you've got all these systems, you being close to the loop. How will you get people to onboard? How will you get people to use it? Now, if you're in the clinic and you've got them face to face, we like do this in HOPES, we do this in polyclinics. We can face off to a patient and say, look, you've got this thing can help you get better. You might have to pay for it. It might cost $3 a month or something to be on it. But it also might mean you only have to come in for appointments half or something, right? So yeah, we need things like that. It's going to cost you $3. Why do you have to pay $3 a month? Why doesn't MOH just like throw it in? No, they want you to pay something for it. And by the way, if you read McGlynn, you know what the biggest problem in healthcare is? McGlynn, the paper I told you about, we only get 55% of the care that's recommended. You know what it is? It's not. There's this myth that you get overuse of the healthcare system, and that people are like over-servicing and they're over-consuming hypochondriacs. It's absolutely false. Read McGlynn. Almost everything is an instance of underuse and under-deployment of known, valid, highly evidence-based therapies. Read the paper. And it's shown by WHO. We've measured data around the world. The biggest predictor of poor use and poor outcomes is fee-for-service. It's out-of-pocket. Out-of-pocket is, that data is a little biased by poor country results. Out-of-pocket is the killer. Even asking someone to pay $3 is going to wreck outcomes for your country. So I don't know why we do the $3, but we do. Try to get that changed. So how do you get people on board? Don't charge them. But if you have to charge them very little and give it back to them. Sometimes we have clever ways of giving. By the way, in the research world, it's great. You can give them an inconvenience fee, and that will be approved. So you can actually give them all the money back and get them. So that's another beauty of research. And the other thing is, it's not just about getting people on it. To sustain them, it has to be fun. And it has to be, you have to feel reward from it. You have to feel maybe connection with a connected care specialist. And you have to feel it's doing something for you. Otherwise, people give these things up. So that's one thing we haven't done very well yet, which we all should do, is how do we create dopamine as a result of this and reward and feel really good from being on this study. There are a few people working on that. Gamification, there's not many people on that. So all these fantastic opportunities came out in group 2. And the other groups match this.
Okay, Jimmy, would you like to share? Thanks. I didn't know it was a competition. I thought it was a collaboration, but yeah, I'll start with the experience in mind, all right? So, so group 1 is focusing on discovery of digital biomarkers. So we started, I think, what we can, all in my group, what we can come to understanding is that the data actually, quite a lot of them are the data. They do exist out there in the universe, right? The issue here we have is that the data exists in silos. One company, one project has its own data of this source, and we don't get to see each, and access to that becomes a bit challenging. So industry has got data. You ask, maybe Apple has got probably the largest data set around the world. Google probably has quite a lot of data as well from the Fitbits and all. Whether we can ever have access to that. Somebody talked about CCTV. Yes, Ministry of Home Affairs through the poll camps probably have a lot of video data as well. Robert probably knows more about the data than I do. You can speak to me about that. The size of the data sets also vary quite significantly. And really then the question is, should the first primary effort be simply to gather new data, or should we try to stitch data together? Whether the AI can actually help us to do that. The second thing that we went into was actually then what kind of novel data are we looking for? So new sensors. I think there's someone who was developing sensors for things like cortisol and sweat, EEG kind of cortical activity kind of sensors. Second is ask whether, based on the current digital data that we have things that are about social determinants of health. For example, your social economic status. I think May from NHGH as well asked that question. We may not be able to measure directly your income, like we can, but we don't measure digitally, or we don't look at your bank statements. But maybe we can create digital proxies, and maybe this is what Team 2 should try to aim towards to help. This Team 1 really is to develop feature engineers that can help us give us proxies of socioeconomic status. The other big question that we asked was, are we able to synthesize data without data existing? So I heard that Synapse is trying to do that for depression or certain conditions, trying to synthesize digital data sets without actual data. So then the challenges that we have. So earlier in the morning, I think Michael Meaney, who is not here now, spoke about collecting prospective large kind of data sets. That is of course ideal, but it's really expensive to do. And when we go along that line of thinking, does it mean that with each new digital sensor, we need to then collect new comprehensive intra-individual data to make sure that we can triangulate? We think that maybe AI can again help us in terms of stitching, again look at interpolation of different data sets. That will help to reduce the cost of gathering these data sets and improve the implementation of such data. So scalability becomes actually quite a key important consideration. It takes 5 years, right? If you minus away the time of getting a grant, the number of rejections you have, it will take 10 years for you to even synthesize a actual data set. Okay. So the challenges we've had, data that we get today because of this kind of, in the digital setting, is entirely creating a new paradigm of challenge for us because it's longitudinal, it's 24/7 possibly, which I told my team that in clinical practice today, none of us actually take a look at. We don't evaluate clinical data over 24/7, 7 days a week kind of setting. So this poses a significant challenge. The data is extremely novel and too novel. You saw Kwa talking about all the different kind of feature engineers that can create. They are creating more features that we and clinicians and us can actually make sense of. Next, should we go for quality or do we go for quantity in terms of data? So is it important for the data to be technically extremely accurate? Or is it important more to have more data sets to kind of balance away the noise that we get from the data? So to this point, we think that it is important to collaborate, and this has to be an interdisciplinary collaboration, and maybe like what we see today. So it's not just data scientists, we need to have the users, we need to have the clinicians as well as even the social scientists on board. So we can take a look at actually what kind of data that's required, how to make sense of the data. We did talk a lot about structure and governance. I think this will probably pop up other things as about challenge. So data access, data sharing, these are huge problems that we still don't find ways to go around today. So engaging our policymakers, engaging public as well is important. We're trying to expedite this process. We think the public is extremely important. We're going to talk about digital data. So today, currently, this is the era of paranoia, scams, as well as data being hacked. Media helps to report that and fits into the paranoia. So we need to find ways and means to push out some form of public engagement so that there's a bit of understanding, not just in terms of use and share of the data, but also how do we go, the extent we go into protecting their privacy, right? So after that, during lunch, I created my own space model. So AI for, and really, this was the question, what are we going to use the AI for? AI is means, right? So it has to go back to then again the use case. We can collect whole sorts of features, but really what's the use case? Whether this is in a specific group, for example, mothers, in a group of patients with diabetes, or we talk about population health kind of setting, just looking at physical activity. So the use case needs to be made. AI can then be deployed in such use case to take a look at the digital markers that are available. And then after that, to close a loop, what is the clinical care protocols, or basically the care models that are required to implement and bring about the change. And the evaluation metric needs to be put in place. So underlying everything, what our group felt was actually trust, not talking about MOHT trust, but actually real human-to-human trust is actually important. So we have the data providers, and this is you and mine, as well as patients, the data scientists, the healthcare providers who will be using actually the insight from generated, and we have the public as well as the media being involved in this. So we think this is an extremely important setup to consider when we want to think about even try to discover digital markers for our use. I hope I did you.
Thanks. Maybe. So my group, our topic was actually the same thing I just gave the talk on, which is how can you expand all these tools and technologies that we designed to new patients, new conditions. So actually because a lot of people don't know the actual techniques that you can use, so maybe folks couldn't comment on that, but we did brainstorm different use cases actually that we are inspired by. So some of them, for example, we heard a lot from a nurse. Oh, sorry, I should talk about our group. We had an occupational therapist in our group, a nurse at IMH, both at IMH. We had 3 data science researchers, some students, some experienced, Gaofei from A-Star, IHPC, who we also know very well, and a lot of our MOHT interns were on our group as well. So since we couldn't comment on that, we talked more about applications. One that was brought up was actually nurses at IMH. One that I really like the idea of is trying to detect when someone is about to get violent. And actually, if you could sort of detect it and alert to it, then maybe deploy a nurse to kind of manage the situation or something like that. That was then related to this idea of dementia and delirium management in nursing homes. So again, the idea being if you could sort of detect amongst many different nursing home patients, for example, I'm not sure if patients is the right word, detect when they are, say, have delirium or need help, deploy a nurse or even a doctor to go and address it. So those technologies probably maybe very, very similar. Maybe there could be some transference, even the technique. Though the modality, I guess, in IMH, we talk about possibly it'd have to be a video system if you want to detect when someone's going to get violent. We did think that actually it's probably something you can detect with video, but one point that I like that was brought up by Gaofei was that actually there's probably no video camera that's high enough resolution that could probably pick up facial features, which is probably your main cue of some of these signals. So he said that instead you'd probably have to rely on just gestures, sort of at the gesture level. What can you actually get out of that? Can you detect oncoming aggression from gestures? I'm not sure. Going back to the example in care homes, can you detect, like, let's say things like Parkinson's dyskinesis? Actually, yeah, people are trying to do that, right? People can detect that with cameras on the gesture level. You don't need sort of facial features. So that was, I thought, some very, very interesting sort of ideas, and really kind of talking about the limitations of that actual device itself, right? With your camera, you just can't cover an entire hospital with high definition cameras. Same thing with nursing home example. Is it going to be cameras that you're using in there, or is it going to be a wearable device? Is it a Fitbit, or is it something you put on the ankle? These are sorts of the considerations that we have. We also talked a lot about the applicability of the HOPES strategy, where we try and monitor patients who are post-discharge from the psychiatric hospital. Actually, we talked about that in many different scenarios, actually healthcare in general, for many different patients that you want to basically discharge. We even talked about a non-health example. Someone said maybe prisoners who kind of reintegrate into society was talked about. A lot of this discussion. The call was for a lot of video, though I noticed we had a lot of video requests in our discussions. Let me move on to the bottlenecks, and the answers to the last 2 questions are all kind of the same. The bottlenecks, which I thought was super interesting, we had a researcher on our team who had worked with US groups and pointed out that in the US, you often have these very large research databases that are available to everyone. And actually, they mentioned that in the university hospital system they're working at, actually all research studies that you enter as a patient in that research hospital, by default, you are entered into a research database that is made public to researchers. You have to specifically opt out of that. So we talked about it. You'd never see that in Singapore. Oh, well, I don't see that in Singapore. Correct me if I'm wrong, right? And actually, Gaofei brought up a good point. Even if you have the data, you cannot, contractually, you're not allowed to use it for purpose other than the research that you have under your contract with whoever you collected it with, or IRB, right? IRB approved you to use it for a particular research project. You'd have to go back to IRB and get reapproval to use that data for another purpose. So he points out a good point. Even if you have the data, you can't often do this transfer, right? You can't even do this transfer learning. I thought that was a super interesting point. We try and deploy things like trust, right? Trust putting this data in. I thought some good ideas I heard was that maybe there was a proposal. Anyone who gets funded by NRF research grant funding, they have to commit their data to trust and make it available to trust users. I like that proposal. So that was, and yeah, so that's a condition of getting NRF grant funding. That was one proposal. Last comment, one researcher in our group said that, yeah, they applied practices to trust and wanted to use it for their work at a public hospital, but it was too expensive and their project couldn't afford it. And so, you know, that also, it's definitely a limitation, definitely a bottleneck here. I think that's the main points I wanted to communicate. Yeah.
Thank you. So for the discussion group 4, we talked about how can we make use of research so there's really good clinical studies and using real world experiences. And I think what Dr. Jimmy mentioned earlier, there needs to be real collaboration. We cannot just simply work in our own silo and data scientists looking at data and clinician looking at patient, but there needs to be this really trust and collaboration between all of these expertise so that if I have an AI algorithm, I can actually apply it in the clinical setting, working with clinician to recruit patient flows. So being able to have that buy-in from clinician so that they know what we're doing and they believe in what we're doing together, and they can actually go and sell this to the patient and recruit them to the study becomes crucial. I mean, to find people with diabetes is not difficult. There are tens and thousands and hundreds of thousands of them. But how many percentage of them are willing to come and participate in the study? That does require a great deal of trust, communication, and buy-in from all the parties involved. So that is one way for us to be able to really test and validate our work in real-world setting. Now, once we have the buy-in from clinicians and all the different parties, and we form a really cohesive working group or research team to implement the study, everything seems to be going well. And once the study is over and you prove that something is working, then the next bottleneck is, how can I integrate this into the larger ecosystem? So, for example, an NTU's or NUS researcher develop an app writing their own code. How can that app be integrated into Health 365, for example? How can it be integrated into Health Buddy? And the bottleneck is really because me not being part of that ecosystem, I don't have access to source code. I don't have access to the program itself. How do I integrate? Another challenge that we eventually see is, let's say I do want to collaborate with the people who have established Health 365, for example, and I want to be able to work with them and collaborate with them and build Meaney app on top of the super, right? The experience that we had is that when we have these collaboration potentially, the people who host the super app wouldn't give us the source code. So we would give them the idea of what we want to do, and they would use their own team to do it, and then they create it together at the end. Well, who owns this? It's our idea is the data is collected together, but then it's built on your platform. It's only works on your platform. Then ownership becomes a challenge. Let's say we don't need to integrate into the larger system and we use it as an individual app, right? And it could potentially be helpful because if you think about having super apps, within super app, there's so many different apps that can confuse patients. Sometimes when we talk to patients on the ground, they only want one simple thing, one app that does a few things, and that's all they want. And that's perfectly fine. So if we are to commercialize a standalone app that we have created together with this whole team of 20, 30 collaborators, then the next bottleneck is then, well, how does the commercialization process evolve? And can we come to a conclusion and consensus in terms of sharing intellectual input? And this has often been a real challenge because let's say the work is done and everything is good and we have an investor that's willing to come in and pump money into research and development, you cannot get this started without a technology disclosure being signed. And every technology disclosure seems to be different. And there's a lot of nuances within those challenges. For example, let's say you have a group of 30 collaborators and co-investigators, and not every one of them have the same amount of work that's been contributed, or manpower, or hour that has been contributed to it. And so at the end, when we have to put together TD and we talk about intellectual input and sharing ratio, who gets what percentage? Could there be a standardized way or guideline in terms of how that can be done? An example would be, let's say, like we have a group of 20 people in the same team, and many of them actually just review 10 pages of text. And so at the end of this, we said, well, given the work that you've done, I'm going to offer you this sharing ratio. Oftentimes the clinician have no problem. But when they bring back to their corporate office, then the corporate office would have a, and they would come back and say, hey, I want much more than what you're offering. And that number is often arbitrary. Where are you basing this number on? And so if we're not basing it on the amount of manpower and hour that's labor that's been put into project, the next thing that would usually happen is they look into research agreement. And within the research agreement, there's in-kind contributions. And a lot of the in-kind contribution we don't pay attention to, at least not until today. Now I pay a lot of attention to it because once we get down to the sharing ratio discussion, they look at in-kind contribution. If I have so much in contribution, I should be getting more. So instead of leaving it to the researcher and the clinician who are not business people to have such a business discussion, I think there needs to be a national guideline or institutional guideline on how these things should be done. Instead of leaving every researcher to fight for their own intellectual property rights. The same goes for sharing of source code and having integration of platform. Could there be a national strategy or guidelines of how this can be done? Could there be agreement that can be signed whereby researchers and app developers can have access while also protecting the rights of the people in the super? We also talked about the potential resolution to this is if we know that this product can potentially be commercialized, can we also at the very beginning set aside the equity pool? So let's say there's 20 collaborators or 4 collaborators, and they're only drawing sharing ratio from that existing predefined pool of money. Then it can reduce a lot of that disagreement or argument in the future. It's sort of working like an employment stock option plan, as members of our group have talked about. So I think there needs to be, a top-down process of setting regulation and also bottom-up process whereby we talk to clinician researcher and say, what are your experience like and what's the best way to go about this? Because right now there isn't any structure, there isn't any guideline, and the bottleneck is the worst case scenario is we spent 3 years doing a project and we got to a really good outcome and we want to be able to commercialize it. We couldn't get the TV to sign and it's definitely money. And that a lot of money and the resources people is different. So that's pretty much what we discussed. Thank you. Thank you.
Yes, our team discussed data availability and utilization while protecting ethics and safety. And we had a really nice team, a really nice mix of people. So we had some software engineers, some scientists, both quantitative and qualitative. We had a representative from Epic. We had some clinicians. We had Professor Michael joining us as well. And I will answer all of these questions kind of in one. So we started off talking about data accessibility, and others have touched on this as well. We have really good systems now to share data across research groups like Trust and Biomed DAR. But these clusters are not designed to actually host services more live. And when we start to think about machine models, we might actually want to update these on a monthly or a weekly basis. So these systems are already designed for that. And then other systems such as Epic, they're really designed to be operational. But it's quite hard for research to access that because it can take a really long time to even apply for access, and it's not really clear what you have to apply for. And they often require you to be very specific in the data you need. So it's not good for exploratory research. And as Koa mentioned as well, healthcare is actually very research focused and evidence based. So this whole distinction between operations and research is 2 very distinct silos. That doesn't really work in healthcare as much anymore. So in terms of the type of data, we talked about clinical data and non-clinical data, which is behavior data, for example. So in terms of clinical data, that's the 10%, right, from the first slide today. That's kind of on the way. It's improving a lot, and the clusters, have this master agreement with each other, so they start sharing data But when we talk about non-clinical data, behavioral data, lifestyle data, that's partly not even being collected, and it sure isn't, shared, or there's no infrastructure in this. The second thing we talked about is more about data ownership. So here we have some interesting ideas. We talked about this. Professor Michael at the in Singapore, there's a strong sense that the clusters really want to own the data, but there are alternative models in the world. So in Canada, they piloted a project. MOHT recently met with a team in Scotland, which is kind of the MOHT in Scotland. It's a public sector innovation team. They've also developed another alternative framework where instead of the cluster owning the data, it's actually the individuals that own the data, and they can kind of choose ad hoc, who they share the data with, and that will solve a lot of these data issues as well. Okay, then we talked about data collection. So within that, we talked about incentives. So sometimes we collect data and it's more for the researchers and for the clinicians than for the patients themselves. So we kind of emphasize that it's really valuable to provide real-time feedback for patients, so they can actually have a strong incentive to actually share the data. And yeah, like the idea from COA is also interesting with this opt-out much, those are really ways to kind of improve data collection as well. But of course, there's this issue of consent. So, many people, they're not very keen to share the data, even though they already share the data with all of the tech companies. So we kind of discussed the dichotomy there, where on the one level, it seems like people are very privacy sensitive, especially with digital phenotyping data. On the other hand, they actually share all that data already with all the tech companies, and they don't really complain about it. So we might actually be talking about some kind of bimodal distribution of people, where some people are very keen to share the data and others are not. And this also really ties into the fairness element, because historically healthcare has seen these injustices. For example, that most medication has been historically only validated on men, and we want to avoid that. We replicate something like this where treatments work much better for the digital savvy people compared to the ones that are not working online. Then we also talked about the private sector. So you also touched upon this. Apple, Google, they have like massive data sets that could be very interesting for us, but it's not really anything in place to really share the data across from the private sector to the public sector. And this also kind of ties into this idea of transfer learning, right? Like Singapore, we're very innovative, but we're always going to be limited by a small population. So we need to get lessons and insights from data sets globally into Singapore, and often they're by private institutes. Okay. Another interesting point we talked about is to really focus on action. So a lot of researchers, they focus on like predictive analytics, but it's not really actionable. So one project that was run in Singapore was to test very young children, like 4-year-olds, to predict how well they're going to do at schools. And very, very good performance in the models, but we really want to go beyond that. So this study actually, through these machine learning models, it can actually extract what exactly is causing them to not excel at schools. So it can even be as simple as not speaking English or manual, and these kids are generally very struggling at schools. So then the actionable insight for teachers can immediately be like, okay, well, maybe we can provide them with more language skill courses. And the other thing is, for the research community to focus more on perhaps is this idea of like what incentivizes people to actually share data. Because here also there's a bit of a paradox. People find it boring to read 1-minute article about their health and their conditions. At the same time, and they find that really boring already. At the same time, they can spend hours reading about astrology and it teaches them about the relationship. So I think this could be an interesting thing for the research community as well, to really dive into like what really drives people. Like, why are people so much more interested in some things than others? And then we can design programs more around it. Okay, the last thing is more about bias. So there's a lot of talk nowadays about model bias, and a lot of these open source models that have huge biases in them. And of course, a lot of this is caused by the data that's fed into them. So if we talk about transfer learning, we take ChatGPT and we try to build a product in Singapore. It's going to work really well in English and also in Mandarin. It's definitely not going to work as well for Tamil. So this is another thing we really need to think about. And this is, so AI Singapore has launched a project with C-Cloud, so Southeast Asian Language Cloud. And they really try to collect more regional data to make these models, less biased and more applicable in Singapore. That's also a project I'm involved with because of that reason. Okay, that's all for me. Thanks.
So thank you very much to the breakout leaders. So we are almost at the end. I'm going to ask Robert to give a closing statement.
I just want to thank everyone, the speakers and all the contributors. It's been a very dynamic session. Actually, just before getting into the closing comments, I just want to throw a bit of light on Andy's comments about intellectual property sharing, etc. And I think there's an easy way out of these issues, which is relatively easy way, which is the first thing, since a lot of our work, the work we're doing, the work that we're talking about being funded and the great generosity of this extremely well-funded institution called NRF, which is very well-funded for per population. We've got to focus on, if you want to create economic development, and I am all in favor of creating spin-offs, startups, etc., focus it on the external market. That's where the big market is. Focus it on Europe, US, other parts of Asia. Give us freedom of action in Singapore. Because it's a tiny market. You'll never make any money. You probably can't even support a startup out of Singapore. So let's first make sure that we have equal access and we have open collaboration, that every one of us in this room is freely sharing. We freely share our source code. We share everything we do. We have patents. We share those patents. Let's share with each other and just become fantastic as an island and not let any of that stand in our way. I'm not the first to say this. There's a principle in public health that's been articulated by the leadership, which is we will fully share with each other. We will not have no patent wars or IP wars. We'll share whatever we have to share to make Singapore successful and improve the health and well-being of Singapore. On the other hand, we're an export economy, and we will also develop intellectual property companies to export to give us leadership, and we're already doing that in several fields. Not enough in healthcare, to quite a great extent in financial services, in trade, ports. We're very, very good at that. We even have a strong, you may not know, we have a strong plastics and petroleum industry. It's one of our key exports in Singapore. So let's focus on external markets and try to make sure we have complete, open, and unfettered collaboration between us. And I think if you do that, and then in terms of those tricky discussions, and you're absolutely right, people do get into, particularly around startups, get the help of people like David Wu and the Digital Health Accelerator. That's what they're there for, to help people work through that, to help you to get those things started up and spun up. I've also been working in IP for most of my life, and if I can help anyone, I'll help you with IP as well. So with that, just getting that out of the way, which is we are all one family here. And that, by the way, includes we welcome our friends Epic and Phoebe and so on into that family while you're in Singapore. And even collaborations with Hong Kong, I think are like tremendous. Let's do it. Let's share data and let's get work done. So with that, I want to just wrap up for the day. But I actually want to get your impression. And the way I thought of doing that was, this is not AI for X. This is not AI for healthcare. It's not AI for mental health or diabetic foot ulcers or AI for detecting depression or reducing the burden of diabetes. It's not. It's actually, and we have to be careful about that because there's actually plenty of programs that fund that. They're very generous programs. They're not even spending all their money. So go there if that's what you're looking for. That what our mission is using AI to accelerate the process of discovery and research so we can more quickly center in on these very hard, insoluble, very difficult to solve problems of that Napoleon's March, where we've got tremendous data, we've got tremendous care techniques, we even know what to do for 100 types of cancers, and we just don't give it to the patient. And if we give it to them, they deploy it, or they can't afford it, or something else goes wrong in the process. So I want to go back to that central tenet, which we tried to communicate in the setting up of this, which is it AI, can AI accelerate the science, the discovery, the finding of the biomarkers, the finding of the interventions, and very, very importantly, the cancellation of Napoleon's March and this narrow funneling down where none of this fantastic innovation, or very little of it, often finds its way to patient outcomes. Can we use AI to thicken that funnel, that like loss, that very lossy pipeline? Can we, when we put plumber's tape around and repair some of those? So I want to do a poll, and you have to put up your hand once. You cannot keep your hand down. So the question is, can AI speed up, not just speed up, but make more productive? Because these are big projects, some of them. Make it more productive either by speed or cost or productivity or effectiveness or, you know, choosing the right targets. Can AI do that? Or would it be better? There's 15 other topics, by the way. There's financial services, there's climate change. They all want to use AI, drug discovery, material science. I can't even count them all. Maybe Kedar could. I bet he can't remember them all, right? Should we leave it to those guys? Do they have a good shot? And I'm not trying to bias you to say you should vote for us, because I know you're enough. I want an honest evaluation. Yes, maybe, or no. And, you know, as researchers, yes, you could say, if you're not sure and think we haven't proven or given enough evidence, vote maybe. And if you think it probably can't make much difference, you still need RCTs, and RCTs are very expensive and have nasty IRBs supervising them. So you have to vote yes, maybe, or no. So should we start with, which one would we start with? The least, okay, let's start with maybe. How many people, you have, now I'll give you like 10 seconds to think. You got to vote yes, maybe, or no. And be very honest, your best intellectual honesty hat on. This is not biased by the fact that, you know, you think there might be something in this for you. Your best intellectual, and we will not take names in this vote either. So who thinks maybe? Huh? No, I'll vote maybe. I'll vote maybe. Okay, I'm voting maybe. So I'll kick it off. I actually vote maybe. I think it's not. I think the case is decent, but it's by no means for sure. I think it's maybe. How many people vote yes? Quickly count, please. 20? Okay, put 20. Okay. And how many people vote no? Okay, Kelvin, Professor Kelvin. What? Come on, more than one. There's more than one. There's more than one in the room, you know, because we have not everyone's voted. But one, got one film. Now I played a trick on you. I'm going to move my vote from maybe to yes. So 21-5. I just played a trick to try to get you to be. Okay. Yeah, so that's what we think. And actually why might we be, if I can maybe summarize, why we might be thinking that way. I think it's actually what are the components that you need? You need the data. Actually, we have a lot of very good data. Some of the data is quite noisy, like we have not very good coding standards. Praveen still here. We don't have very good coding standards, but we've got a lot of very good longitudinal data, some of the best in the world. Okay, HPV data. We have the largest schizophrenia database, we think, in the world. There might be a larger one hiding in China, but I doubt it. Right. So we have the data, and it's not all here. It's being collected now, and we're now setting up to have a very good continuous collection process. Do we have the techniques? Are the techniques sufficient, or are they totally missing? I actually think they're only half there. So I think the basic machine learning we can do, and nothing's going to be very hard. Accelerators are not going to stop us for the basic machine learning on the longitudinal records. However, I think for LLMs and for foundation models, it's going to be a real problem. And the reason is that there are a few large techs that dominate the whole LLM space. Fortunately, there's an open movement, for LLMs. Meta is behind it, IBM's behind it. Some other, Anthropic is not. Microsoft and OpenAI are very close. Google's very close. That's who we're up against, right? And the models are going to cost over $1 billion to mine per mining. We don't have that kind of money. So I think we have to invent new techniques, and we can lead as computer science. And I think federated LLMs are going to be very important, which is you mine, we get stuff already pre-mined and selected from Elsevier. So they're papers that they control. We won't be able to do the raw mining unless we want to break the law, which other people do, but we can't break the law. We're going to remain ethical, and it's very Singaporean. If you haven't figured that out yet, we're very law-abiding. And I think that's a great feature of our strength and successful economy. So I think that needs a lot of research. I think the transfer learning, the techniques, it's a very powerful concept. We're going to have to do basic research on that, make that work. So I think we have the data, we have a handle on the techniques. We have the problem statement. People are, we're aging faster. The OECD, we're in the 75th, 80th percentile of oldness. So our average age in OECD, in rich countries, mostly rich countries, we are older than, our average age is older than 75% of the OECD. We're aging faster. And our gap from health span to lifespan is growing. So we're going to have a lot of old, suffering, lonely, incapacitated, immobile, sad, much loved grandparents, etc. We're giving them the life that less than the life that they deserve, the pioneer generation. They earned something better than that. We're not giving it to them. And then the two succeeding generations. So we have the problem. And if there's anything that's not inspiring about the discussions of the statements of the last few days from the former Prime Minister and the current Prime Minister, we're going to focus on things like that, and for everyone in the society. So I think that's last few days have been extremely inspiring. And what does that tell us? First thing, health. I think it's health before anything, before wealth. Wealth's there. But we're also going to suffer tremendously from that health. So the data's there. It's coming. The need is there. The social need is there. The humanistic need is there. The political will is there, I think. We've incurred a huge increase in healthcare costs. It's going to keep increasing. Better do something about that before we have to level it off, because Singapore will not be irresponsible in any form of spending. We can guarantee that. And there's also a whole question of business models. So I think we've uncovered a lot of optimism today and potential around the data, the techniques that were described here and here and here and here, and also the open questions and the need for research to do it. But if we do it, if we can address some of those problems, we're in a unique position. I also think we can export it. By the way, there's a little trick in export. There's one. Singapore is a small country without natural resources, and it has one attribute. By the way, all the growth, economic growth, almost all the economic is going to be in Asia in the next 50, 100 years, right? Singapore has one distinguishing factor from all other Asian countries. What is it? One attribute that differentiates it more than anything else from any other Asian country. Now, I know you're very smart. Singaporeans are very smart and very hardworking and very honest. So it's not that. It's actually a little bit related to it. What is it? What is the distributing attribute? It's on the center of Jimmy's chart. It's trust. Singapore is there are only two countries in Asia where there's any degree of trust. Institutions are broken in most of Asia. Corruption is everywhere. Basically Singapore, to some extent Japan, but Japan cannot communicate and cannot respond and cannot cure its ills. Japan is unable to reform from a whole variety of reasons, not the least of which is its birth rate and denial of immigration and all of those things, which Singapore balances very well. So yeah, trust. Okay, once you have trust, one of the big problems with data, healthcare data is the #1 target of fraud, not financial data. Healthcare data is the #1 target of fraud in the world. because it can be used for insurance claims, insurance fraud. That's why it's widely exploited. The biggest healthcare provider in the US, who's called United Healthcare, Andrew Whitty, who's known to some of you, just paid $25 million without any questions to a ransomware. They just paid 25 million on the nose. It's very easy to get money from healthcare. And it's the ideal place to go for blackmailing data and for compromise. And as the tensions increase, as they especially will in Asia, where great powers meet, Southeast Asia is the meeting point of the great powers. And that's where the battle for growth and for influence will be in the 10 Southeast Asian countries. And that will be, it's being practiced. There are spies, not in this room, but there are spies all everywhere. And there are people trying to embarrass Singapore and trying to keep Singapore down. And that's part of the great power struggles. And it's not just one country, it's multiple countries are trying to create trouble and mischief. And one of the key methods that they're using is healthcare data. Okay? So we should make no mistake about that as we work on data security with Lian's not here. As we work on data security, it's extremely important. So we also have to do in the presence of that. But if we do that right, the fact that there's all this corruption, not just in Asia, but in the rest of the world, and problem with data leaks and blackmails and compromise and ransomwares and everything, also means that if we can, why does Facebook put their main data center in Singapore? Because of that trust factor. Why are many companies headquartered out of Singapore and they're rapidly moving? Because of trust. We could exploit that. We could run the world's data centers for health with all those algorithms that we've been talking about, and we could export that. We could take data, we could process data, we could export data. And that's the kind of export industry that we're looking for. We're not looking for labor-based healthcare industry because we cannot scale it, because we don't have the people and we cannot just do the immigration freely to scale it up. We're looking for tech-based that has zero marginal cost of scaling. So therefore, that's a huge opportunity. People are thinking about that in IMDA, a lot of work going on in IMDA around that trust logo. What it can be done, and one of the prime industries that it can be done is in health. We're not going to be able to draw blood for everyone because you can't scale that, but we can provide advice, and we can be a repository for data, which is relatively impregnable if we do it right. So anyway, those are some of the things I think probably should be very optimistic. I think that we voted very convincingly that this AI is going to do this. And please.
First of all, I'm not doing something against all of the group, but in using AI in the healthcare industry, in my experience, we work faster but get wrong, and then we go back again. Sometimes we burn out our time. So I think until the techniques and data sharing, all the stuff is more settled, and then we are more interdisciplinary team, or we speak the same language, then I'm quite sure that AI is much faster than our traditional way of thinking.
Fantastic point, Cohen. And we can, and I see us actually shooting, and I know it happens other places. We're shooting ourselves in the foot from time to time in Singapore. And the way it happens, by the way, is around careerism. We have competitiveness set up with our 3 clusters in Singapore for a reason. It works quite well. It has to be regulated because sometimes it's over competitive, and sometimes at the individual and the team levels, it's over competitive, and it needs to be collaborative. There's also other blockers in the system that you talked about in the group, which is the ability to build beautiful systems that can never get into patient care. And that we all suffer from that, and we just got to put the pipe band-aids on and stop the leak. And I think there's ways of doing it. I'd love to talk with you offline, and maybe you've learned techniques in Hong Kong that we haven't learned yet. And we may have learned some that you can use, because Hong Kong can still be a very good partner for us. I have many friends in your institution, CUHK. So I think I've talked for long enough, but just like to call on others for their closing comments and where we should go. The next steps, we're going to do a summary, which we circulated. We'll work, Yang will lead and others will help on we'll submit a 5-page summary of what we learned today. And then the next thing is there's a group leaders meeting which has just been moved to 5th or 6th of June. 7th of June, okay, it's just been moved. But we'll all get together and compare notes from the 15, 16 teams. And then you saw the map from Kedar. He said there'll be a grand challenge, set of grand challenge statements. And by the way, they plan to start with a few, but there's really, I think, no limit. There's a lot of money in NRF, and they'll do more, and they'll do whatever is needed, I think. So they will fund a number of different grand challenges. With that, I would like to just hand the mic to anyone else who'd like to make some closing comments. You're the
Well, I don't have any comments. I think quite an interesting session that I had. Yeah, I just look forward to the summary that we shared. Yeah. But I do take the point of interdisciplinary one, Andy just talked about. But I think that's extremely important. I think we can lay all in silos. I feel that there's a lot of work that we can do together just to make sense of it. I also face the challenge with data sharing and all on a daily basis, and it is something that we need to address. I'm not sure whether it's within the ambit of the team or basically at the market level.
Actually, any comments from anyone like
who's a little bit out of the mainstream here, like Epic or Phoebe or Alan, like to make any comments? Cullen's very associated with a US outfit. Actually, his group, they kind of started digital phenotyping. So maybe Cullen, maybe you could make
Sure. Yeah. Just the only thing I'll say is really fantastic seminar workshop here, and I think we're really excited about the potential for digital phenotyping to be Singapore to be the hub of this kind of technology. And you know, these things take time. I think that's another thing that came out, but very excited to see all the things here happening, and yeah, looking forward to the next meeting.
Yeah, thanks. And also colleagues
from Epic. Epic is a very unusual, inspired company in terms of what they do for very high quality software that runs healthcare systems in the best institutions in the world. And we've just joined that. We couldn't be not there since the best institutions here. So maybe one of our Epic colleagues would like to make that comment. Because you know where the rubber meets the road, because you put healthcare systems into every possible environment.
Yeah, I'm Kayla from Epic. We have an office here in Singapore, about 60 of us in Little India. So we're very excited to have been able to be here today and to meet people that we don't normally work with on a day-to-day basis on the NGMI project. Excited to see where the AI road leads us in Singapore and how we can expand open access of data.
Anyone still from any of the create entities? All left? ETH and others were here earlier. They had to go, I assume. Okay, anyone else would like to make a comment before we close up? We have a third-year medical student who's just starting off. Xin Yang, so you have to make it. You can handle it.
I think as a medical student, it's super exciting to be here because you're really hearing perspectives from all the different collaborators. And I think it's really, really exciting. I'm like super excited to be in the healthcare industry in the future because I think it holds so much potential. And yeah, these people here are like really amazing. Yeah, so thank you for letting me come today.
Thank you. Anyone else can speak? Okay, Peng. Creighton Heaukulani.
Yeah, I guess NRF workshop is why we assembled today and put this all together. But actually, the vision is, we think, very compelling, and all the work we've done and people we brought together today and collaborators, people we want to collaborate with, and created this strategy. Even if we're not selected for the NRF as an NRF theme, I think we should still go forward with it. I've definitely propose everyone that we've talked to today. We absolutely should still take that great piece of work and pitch it, drive forward with it.
And also the pairwise, I saw a lot of pairwise collaborations. People got together, didn't know each other, or maybe only you had not thought about the potential. So I think there's all kinds of like pairwise collaboration. Those will happen, I'm guaranteed. I mean, some percentage of them will, subject to the yield curve, not as much as the patient, not as much as Napoleon, but subject to some lesser yield curve. So some of those I'm sure will go forward. And anyone from NRF like to make a comment? Anyone else? Okay, so I think we're done. So thanks very much for staying on and all your contributions today, and we'll be together in the future, I'm sure. Thank you.